Right now, your brain is building everything you're experiencing. The light hitting your eyes, the sounds reaching your ears, none of that is the real world. It's signals, and your brain turns those signals into the picture you're seeing right now. So here's the question. If your brain is just building a picture from signals, how would you ever know whether that picture matches what's actually out there? You can't step outside your own head to check. And it turns out, physicists ran into this same problem, not about the brain, but about the universe itself. So tonight, we're going to sit with one question. Are we living in the real universe? There is a number that sits underneath everything in this video. How much would the universe weigh if you measured it not in kilograms, but in information? Start with something you can hold. A single gram of water, about 1/5 of a teaspoon, the amount that clings to your fingertip after you touch a wet glass. To fully describe that gram, every molecule, every position, every vibration, every quantum state of every electron, you would need roughly 10 to the 24th bits of information. Written out, that's a 1 followed by 24 zeros. To put a floor under how large that is, take every computer, every phone, every server farm, every backup drive humanity has ever built, and add up all the data stored on all of them. That total comes to around 200 zettabytes, which is also about 10 to the 24th bits. So the entire digital output of our civilization, every photo, every film, every database, every word ever typed and saved, contains about as much information as one drop of water clinging to your finger. We tend to think of the digital world as enormous and the physical world as ordinary. The opposite is closer to true. The ordinary thing is denser, by a margin that isn't even close. Now scale up. A single star, an object like our sun, holds something like 10 to the 59th bits. That's not a star's worth more than the water. It's 1,000 trillion times more. And the gap between a gram of water and a star is itself almost nothing compared to where this goes next. In 2009, two physicists, Chas Egan and Charles Lineweaver, sat down to estimate the total information content of the observable universe. Not the matter, but the information. Every particle, every photon, every degree of freedom in everything we can see. Their answer came out to roughly 10 to the 122nd bits. That number is so far outside human experience that saying it does almost nothing. So here is the only way I've found to make it land. Imagine you wanted to count to that number and you counted 1 bit per second, never sleeping, never stopping. The universe has existed for about 13.8 billion years, is less than #0. 5 hash is greater than if you had started counting at the Big Bang and counted every second since, through the formation of galaxies, the birth of the sun, the entire history of life on Earth, all the way to this exact moment. You would not have made it past 10 to the 18th. You would not be 1% of the way there. You would not be 1/1,000,000,000 of 1/1,000,000,000 of the way there. You would have to repeat the entire age of the universe, start to finish, more times than there are atoms in your body, and you still wouldn't be close. That is the weight of the universe in information. And this is where the question of simulation stops being a movie idea and becomes a problem with actual edges. Because if you ever wanted to simulate this universe, all of it, perfectly, down to the last electron, you would need a computer capable of tracking 10 to the 122 bits. A computer that can do that has to be built out of something. It needs memory, physical memory, made of particles. And here the logic bites its own tail. To store the state of every particle in our universe, you would need at least one particle in your computer for every particle being simulated. Probably many more to handle the bookkeeping. Which means a machine capable of perfectly simulating our universe would have to be larger than our universe. That's not a budget problem. It's not a wait for better technology problem. It's a wall built into the structure of the question itself. You cannot fit the ocean inside a bottle that floats in the ocean. So the people who take simulation seriously already know this. They are not imagining a perfect copy. They're imagining something cleverer and in a way more unsettling, a simulation that only renders what it has to. That fakes the rest. That cuts corners precisely where no one is looking closely enough to catch it. And that idea, the idea of a universe that economizes, that has a resolution limit, that approximates the parts nobody is measuring, turns out to leave fingerprints. But before we go hunting for those fingerprints, sit for a second with how little of this universe we've ever actually inspected. There is a telescope in the high desert of northern Chile, on a mountain so dry and so remote that the only life around it survives on coastal mist that drifts in maybe a few times a year, is less than #0. 5# is greater than at. Its heart is a digital camera the size of a small car with a resolution of 3,200 megapixels. Every clear night, it photographs nearly the entire southern sky and dumps around 20 terabytes of fresh data down the mountain. Over 10 years, it will collect 500 petabytes, roughly the amount of information in every word every human has ever written in every language across all of recorded history. It will map 17 billion stars in our galaxy and 20 billion galaxies beyond it. The largest survey of the cosmos ever attempted. And when it's done, when that decade of relentless nightly scanning is finished, it will have cataloged less than 5% of the stars in our own galaxy and less than 1% of the galaxies in the observable universe. For every exploding star it captures, it will have missed thousands. This is not a flaw in the instrument. It's the best instrument we've ever made. It's the shape of our situation. We have spent the entire history of science scratching at a window, and we have cleared a patch about the size of a fingernail, and through that patch we have seen enough to reconstruct the Big Bang, trace the birth of the solar system, decode the machinery of the living cell, and write down the laws of the subatomic world. We have measured almost nothing, and from that almost nothing, we have learned almost everything we know. If a universe could be faked, not perfectly but well enough, only rendering the parts under observation, approximating everything else, then it would have to take shortcuts. And shortcuts leave marks. Speed limits, minimum sizes, rules that look less like the laws of nature and more like the settings on a machine straining to keep up. We started tonight by noticing that nothing in the universe is allowed to update faster than light. A hard ceiling on the speed of information with no exceptions. That sounded like physics. The deeper you go, the more it starts to sound like a clock speed. We can't simulate the universe. And yet, right now, on machines humming in cooled rooms across the planet, the universe is being simulated anyway. The trick is in how much they leave out and what they choose to fake. There is a piece of software, first released in 2019 and still maintained today, that builds galaxies from nothing. You give it the universe a few 100,000 years after the Big Bang, a smooth sea of gas and dark matter with almost imperceptible ripples in it, and you press play. What comes out billions of simulated years later, are spiral galaxies, clusters, filaments, the whole cosmic web. Not loaded in, grown. The way it works is the first place where the cracks start to interest me. The code does not track particles. It can't. We just saw why. Instead, it carves a chunk of universe, maybe a few billion light-years across, into cells. Inside each cell, it doesn't store what every atom is doing. It stores averages. How much dark matter is here? How much gas? What temperature? What pressure? Which way the magnetic fields point? A whole region of space smeared into a handful of numbers. It's the same move a painter makes standing far enough back that 1,000 individual leaves become a single wash of green. Up close, that green is a lie. From across the room, it's a forest. And the clever part is that the cells are not fixed. Where the universe is empty, the code lets the cells grow huge and lazy, barely paying attention, because nothing much is happening. Where matter is collapsing, where a galaxy is about to ignite, it shatters those cells into smaller and smaller pieces, pouring its limited memory exactly where the action is. The mesh flows with the matter. It spends detail only where detail is earned. Stop and notice what that is. A simulation that approximates the empty regions and concentrates its resources only where something is being watched closely enough to matter. If you were building a fake universe on a finite budget, that is precisely the strategy you would use. We didn't design it that way to imitate a creator. We designed it that way because it's the only way the math fits in the machine. But this is where you should start to push back, and you'd be right to. Because even with all that cleverness, even shattering cells down to the size of a small galactic region, the code still hits a floor. Below a certain scale, it cannot follow what's happening. A single star is far smaller than the smallest cell. So when the moment comes for gas to collapse and ignite into actual stars, the simulation does something that should make you uneasy. It doesn't simulate the star. It guesses. Buried inside these codes are what physicists call subgrid models. When a region gets dense enough and cold enough, the code says, in effect, stars probably form here now, at roughly this rate, releasing roughly this much energy, scattering roughly this many heavy elements. It's a recipe, a rule of thumb stitched in by hand, calibrated until the output looks like the real sky. The most sophisticated cosmological simulations ever built, the ones that produce those breathtaking galaxy images, are running on educated guesses at exactly the scales they cannot resolve. Those simulations are stunningly successful. They reproduce the large-scale structure of the universe with an accuracy that, 30 years ago, would have seemed impossible. The point is subtler and stranger. The only way we know how to make a convincing universe is to fake the small stuff and get the big stuff right. Render the structure. Approximate the interior. Trust that no one is looking closely enough at any single star to catch the recipe standing in for the real thing. Which raises a question. If that's the only way it can be done, by us, with our physics, then is there any reason a more advanced version would look fundamentally different? Or would it just push the recipes down to a finer scale, hide the seams a little deeper, and leave the same kind of structure we're about to go looking for? There isn't one obvious way to carve space into cells. One family of methods does what I described, a flowing mesh that bends and splits with the matter. An older family throws away the grid entirely and tracks blobs of gas as particles that drift and clump on their own. Each captures something the other smears out. The flowing mesh handles shockwaves and sharp boundaries beautifully, but can struggle when matter swirls violently. The particle method follows the swirling but blurs the sharp edges. Run the same starting universe through both, and you do not get identical galaxies. Let that sit, because it's pointed. Two different methods, both built on the same laws of physics, fed the same initial conditions, produce universes that differ in their details. The laws are not enough. How you choose to approximate the parts you can't compute changes what comes out. The universe a simulation produces depends not only on the physics, but on the shortcuts. And now bring it home, because this stops being abstract the moment you do. Look out a window during the next rainstorm. We can simulate the birth and death of an entire galaxy. We can model a star collapsing into a black hole. But we cannot simulate that storm down to its individual raindrops. Not the drops sliding down the glass in front of you, not the smaller drops inside it, the air currents threading between them, the way each one shatters when it lands. A galaxy we can manage. The rain on your window, in full detail, we cannot. That inversion still surprises me every time. The thing that feels small and close and knowable, the weather a few feet away, contains more computable complexity than the thing that feels vast and remote. Scale and difficulty don't line up the way intuition insists they should. So our best simulations of reality share a signature, and it's worth naming clearly before we go further. They have a resolution, a smallest size below which the world goes blurry and gets filled in by rule. They economize, spending detail only where it's needed. And they cannot, even in principle, capture everything at once. Every simulation we have ever built has a floor. We started this act knowing we could never compute the whole universe. We end it having watched ourselves build convincing universes anyway, by deciding exactly where to stop looking. So, if every simulation has a smallest resolvable size, a floor below which detail dissolves into approximation, then there's an obvious thing to check. Does our universe have a floor? In 2009, a galaxy was easier to predict than tomorrow's weather. That's still true today, and the reason why is one of the most important things this video has to teach. On the 13th of August, 1958, a team at the University of Chicago did something no one had ever done. A tropical storm had formed out in the mid-Atlantic and was drifting west toward the Americas. They took its measured wind speeds and pressures, fed the numbers into a physical model, and let a computer calculate where the storm would go next. The first time in history a machine looked at the present state of the sky and told us its future. A crystal ball made of arithmetic. What they built that day is now wrapped around the entire planet. Dozens of satellites feed a constant stream of atmospheric data into simulations that never stop running. When a hurricane turns toward a coastline now, we can say days in advance, with real confidence, where it will make landfall. People evacuate on the strength of a calculation. The crystal ball works. And it has a hard floor, the same floor we found inside the galaxy code, just at a different scale. The best weather models resolve the atmosphere down to grid cells roughly 1 to 2 kilometers across. Anything smaller than that, they cannot see. They average it, which means a single thunderhead might be captured, but the turbulence inside it, the individual gusts, the swirl of air around a single hill, all of that is smeared into one number per cell. And below the cell, the same trick we already met. The model doesn't track the small stuff. It guesses, with a recipe, how the small stuff behaves on average. So far, this is just the galaxy story retold at human scale. But the atmosphere hides something the galaxy code doesn't force you to confront, and it cuts much deeper than resolution. Here is the thing that broke weather prediction open in the 1960s, and it started by accident. A meteorologist reran a forecast, and to save time, he typed in a number from a printout rather than letting the machine use its full internal value. The printout had rounded it 506 thousandths instead of 506,127 millionths, a difference smaller than a thousandth. The two forecasts started out identical. Within a simulated month, they described completely different weather. That's the discovery that should change how you hear this entire video. In certain systems, and the atmosphere is the textbook example, the tiniest difference in the starting conditions doesn't stay tiny. It grows. It doubles, and doubles again, feeding on itself until it swallows the whole prediction. A rounding error in the 6th decimal place becomes the difference between a calm week and a storm. The standard image for this is a butterfly's wings stirring air that becomes a hurricane, and I think that image has done real damage because it makes people picture a chain of cause and effect, one tiny push leading neatly to one big result. That's not what's happening. A better way to feel it. Imagine balancing a needle on its point. In theory, there's an orientation where it stands perfectly still. In practice, the difference between leaning a billionth of a degree left and a billionth right decides which way it crashes, and you cannot measure a billionth of a degree. The atmosphere is a trillion needles, each one's fall nudging all the others. The future isn't hidden because we're not clever enough. It's hidden because reading the present precisely enough to compute it would require infinite precision. We said every simulation has a resolution floor, a smallest size it bothers to compute. Chaos says something sharper. Even if you had a simulation with no resolution floor at all, even if it tracked every molecule perfectly, you still could not predict the weather because you could never measure the starting state to infinite decimal places. There is a wall of precision standing behind the wall of resolution. And both walls point the same direction. A system that demanded you specify every quantity to infinite precision would need infinite information to describe a single instant. Infinite storage for one frozen moment of one rainstorm. No machine could hold that. No machine in any universe. Which means if reality stores its own state the way a computer would, reality cannot be running on infinite precision either. Somewhere, the decimals have to stop. That's not proof of anything yet. Hold the suspicion loosely. But notice the shape of it. We keep finding that the universe behaves like something working under a budget. A speed limit on information in the first act. A pressure toward economy in the second. And now, a hint that infinite precision might simply not be available, that nature might refuse to hand over decimals it never bothered to compute. Each one alone means little. Together they start to rhyme. Bring it back to the window, because the storm out there is still teaching. Watch a single raindrop break apart against the glass. Whether it shatters into 4 pieces or 5 depends on currents in the air finer than any instrument can read, on the drop's exact shape a millisecond before impact, on a thousandth of a degree wobble as it falls. The drop's future is real. It will do exactly one thing. But the information that decides which thing lives below the level anyone can ever access. The drop knows. We can't. We built a machine that can forecast a hurricane a continent away, and the same machine cannot tell you how the rain will run down your own window in the next 10 seconds. Not because the window is mysterious, but because the window is chaotic, and chaos hoards its details below the floor of measurement. So weather hands us a second signature to carry forward, and it's worth saying plainly. The first act gave us a universe that limits the speed of information. The second gave us simulations that economize, faking the parts no one resolves. This act adds the strangest one. Reality may be built so that, below a certain scale, the questions you'd need to ask it have no more decimal places to give. The detail isn't hidden. It may not be there until something forces it into existence. That last idea is going to come roaring back later, when we get to what happens to a particle when no one is looking at it. For now, keep it as a thread. Because all three signatures, the speed limit, the economy, the missing decimals, all point at one question we've been circling. The real question is whether reality itself has one. If you zoom into the fabric of space, closer and closer, past atoms, past the particles inside them, down toward the smallest scale anything can mean, does the picture stay smooth forever? Or does it, at some point, turn into pixels? Take the question we ended on and make it physical. Zoom into empty space, past the atoms, past the quarks inside the protons, and keep going. At some point, does space stop being smooth and start being grainy? There is a specific scale where physicists expect the answer to live, and the story of what we found when we looked there is not the story the simulation people usually tell. The scale has a name and a size. It comes from taking three of the deepest constants in nature, the speed of light, the strength of gravity, and the quantum of action, and combining them into a single length. There's only one way to do it, and what falls out is about 1.5 times 10 to the minus 35th meters. The Planck length. Take a single proton, already so small that trillions would fit across the width of a human hair, is less than #0. 5 hash is greater than. Now imagine blowing that one proton up until it filled the entire observable universe, 93 billion light-years across. Stretch everything by that same impossible factor. On that scale, where a proton has become the whole cosmos, the Planck length would have grown to roughly the size of the Earth. That is how far below everything we can touch this scale sits. And it is the place where physics, as we have it, simply stops working. Here's why, and it matters for what comes next. We have two great theories. One describes gravity as the bending of smooth, continuous spacetime, and it is flawless at large scales. The other describes matter as discrete, probabilistic, quantum, and it is flawless at small scales. At the Planck length, you need both at once, and they contradict each other. The equations don't return a wrong answer. They return nonsense, infinities, quantities that should be small ballooning to meaninglessness. This is the part the simulation argument tends to get backward. People hear that the Planck length is the smallest meaningful distance and conclude it must be the pixel size of reality, the resolution of the cosmic screen. But that's not what we actually know. The Planck length isn't a measured floor. It's the scale where our map dissolves. Saying reality is pixelated there is like standing at the edge of an old map where the cartographer wrote nothing and insisting the world must end at the ink. The blank means we stop knowing. It doesn't tell you what's there. Some theories do bet on pixels. One serious approach to quantum gravity called loop quantum gravity, proposes that space is not infinitely divisible at all. In that picture, area and volume come in discrete chunks, the way electric charge comes in whole multiples of the electron's charge. Space would be woven with the smallest possible patch, below which the word smaller has no meaning. If that's right, the universe really does have a resolution, a floor written into geometry itself. It's a beautiful idea. Loop quantum gravity is one candidate among several, and none of them has been tested at the scale where they differ. So we have a real theoretical reason to suspect space might be discrete and no proof. And this is exactly where curiosity leads us to the one question that cuts through everything. Can we look closer? For a long time, the answer was obviously no. Probing the Planck length directly would take a particle accelerator larger than the solar system. But there's a back door, and the cleverness of it still impresses me. If space were grainy, that graininess should leave a trace on anything traveling far enough through it. A photon crossing pixelated space would be like a marble rolling across cobblestones instead of glass, is less than #0. 5# is greater than. A high-energy photon, with a shorter wavelength, would feel the bumps differently than a low-energy one. Over a few meters, the effect would be undetectable, infinitesimal. Over billions of light-years, it would pile up into a measurable delay. Race 2 photons of wildly different energies across the universe, and if space is grainy, they should arrive at slightly different times. In 2009, nature ran that exact race for us. A burst of gamma rays from an explosion roughly 7 billion light-years away reached Earth is less than #0. 5# is greater than 7 billion years. Those photons had been traveling across more than half the age of the universe, through every patch of space in between. Among them were photons whose energies differed by a factor of 1,000,000. If space had Planck-scale cobblestones, the high and low-energy photons should have separated noticeably over that immense journey. They arrived within a fraction of a second of each other. The smoothness of space held, not just down to the Planck length, but to scales smaller still, finer than the supposed pixel by a wide margin, is less than #1. 5# is greater than. We went looking for the grain of reality, with a ruler billions of light-years long, and found the surface polished smoother than the smallest size our theories said should exist. The most direct test we have ever run for reality being pixelated came back negative. Space, as far as we can measure, is smooth. If we are inside a simulation, it is not the crude kind with visible pixels at the Planck scale. Whatever runs this universe, if anything does, hides its resolution better than that, or has no fixed resolution at all. And yet I can't quite close the door, and neither can the physicists who ran the experiment. Because a negative result doesn't prove smoothness all the way down. It pushes the floor lower. It says, if there's grain, it's finer than this. The pixel, if it exists, is just smaller and better hidden than we guessed. We didn't find the bottom of reality. We found that the bottom, if there is one, is even further down than the deepest place our theories can describe. So the floor we went hunting for slipped away from us. The universe declined to show its pixels. But it left something else on the table, something that bothers physicists far more than graininess ever did. Because while we were measuring how smooth space is, we kept noticing how precisely tuned it is. Think about what had to be true for those photons to exist at all. For the gamma-ray burst to happen, stars had to form. For stars to form, Gravity had to have a particular strength. For atoms to hold together, the forces binding them had to fall in a narrow range. Nudge any of a handful of numbers a few percent in either direction, and you get a universe with no stars, no atoms, no chemistry, no photons crossing 7 billion years to reach a detector built by curious apes. No one inside to ask whether it's real. The constants of nature did not have to land where they landed. As far as anyone can tell, they could have been almost anything. And they came out tuned with a precision that has unsettled physicists for half a century. A programmer would have a quick word for numbers set carefully enough to make a system run. So we stop asking what the universe is made of and start asking why it was set the way it was. Why these numbers? Why this finely? And whether tuning that exact is a clue, a coincidence, or something we simply don't yet understand. The worst prediction in the history of physics is also the reason you exist. Those two facts are the same fact, and untangling them is what this act is about. Start with the number that keeps cosmologists awake. Empty space is not empty. Quantum theory says the vacuum seethes with energy, particles flickering in and out of existence everywhere, all the time. You can calculate how much energy that vacuum should contain. And when you do, using the best theory of particles we have, the answer comes out too large by a factor of 10 to the 120th. A 1 followed by 120 zeros times too big. That is not a small error. It might be the largest gap between prediction and reality anywhere in science. If the vacuum truly held that much energy, space would have torn itself apart in the first instant, expanding so violently that no two particles could ever have met. No atoms, no galaxies, no chemistry. The energy of empty space had to be almost perfectly cancelled, down to that 120th decimal place, for anything to form at all. We measured that energy in 1998, watching distant exploding stars, and found it isn't zero. It's tiny but real. Just large enough to push the universe's expansion gently faster, and just small enough that galaxies had time to assemble first. Out of a possible range spanning 120 orders of magnitude, the one value that allows observers to exist is the one we find ourselves living inside. You may have noticed that 120 echoes something. The total information content of the observable universe came out to 10 to the 122nd bits. The numbers aren't the same thing, and I won't pretend they're secretly connected. But there's a shared flavor worth tasting. The quantities that govern whether a universe can hold structure live at staggering scales, balanced on impossibly fine edges. Reality runs on knife points. The vacuum energy is the sharpest one, but it isn't alone. Consider carbon, the spine of every molecule in your body. Carbon is forged inside stars when 3 helium nuclei slam together, and that reaction almost never works, because the odds of 3 nuclei meeting at once are dismal. It only happens because carbon has an energy level sitting at exactly the right value to catch them, a resonance that acts like a perfectly placed funnel. A physicist named Fred Hoyle predicted that level must exist in 1953, reasoning purely from the fact that carbon, and therefore he, was here. He was right. The level sits where life needs it. Shift it by a few percent, and the funnel closes. Stars make almost no carbon. The universe stays sterile. Numbers this perfect must have been set on purpose. By a god, or by a programmer adjusting parameters until the simulation produced something interesting. That feels almost forced on you by the evidence. It is also a leap, and the leap is the whole problem. Here is the trouble with reading fine-tuning as a signature of design. To say a value is improbably tuned, you need to know two things: what range it could have taken, and how likely each option was. We have neither. We do not know whether the strength of gravity could have been different, or whether some deeper law we haven't discovered locks it to the only value it was ever allowed. We assume the constants are free dials that could have landed anywhere. That assumption is doing all the work, and we cannot check it. A radio makes the trap easy to feel. Turn the dial across the band and you hit mostly static, with a few narrow windows where a station comes through clear. Land on a station and you might marvel at the precision. What luck, out of the whole dial, to sit exactly here. But the dial only feels miraculous if you assume every position was equally likely and you arrived at random. If the radio was always going to power on at a station, or if there are a billion radios and you only ever notice the ones playing music, the precision evaporates. The tuning is real. What it means depends entirely on the machinery behind the dial, and the dial can't show you that. That last point is the one to carry forward. Fine-tuning is a real, quantified, deeply strange fact about our universe, and it underdetermines its own explanation completely. Look at how many roads it opens, all equally consistent with the same evidence. Maybe there is one universe, and we don't yet know the deeper theory that forces these values, the way we once didn't know why planets orbit as they do until gravity explained it. Maybe there are countless universes with every possible setting, and observers can only ever find themselves in the rare ones tuned for observers, so the fine-tuning is no more surprising than the fact that you were born on a planet with breathable air, rather than on the airless ones. Maybe the dials were set by something running the whole thing. Every one of these explains the data perfectly. The fine-tuning by itself cannot tell you which is true. So fine-tuning is not evidence for the simulation. That's the honest verdict, and it deserves to be stated flatly. It is evidence that something deep is going on, and it points in 3 or 4 incompatible directions at once, and the simulation is merely one of them wearing the costume best suited to our moment in history. A medieval thinker saw the same tuning and named it God. We grew up among computers, so we look at the same dials and see parameters. The evidence didn't change. The metaphor we reach for did. There's a humbler version of all this hiding in your own body, and it's worth ending on. You survive within a temperature window only a few degrees wide. A handful of degrees up, and your proteins begin to unfold and stop working. A handful down, and the chemistry of your cells slows towards stillness. Out of the whole range of temperatures the universe contains, from near absolute zero to the cores of stars, you function in a sliver. By the fine-tuning logic, your existence is wildly improbable, balanced on a razor. And yet no one looks at body temperature and concludes a designer set it there. We understand that life evolved to fit the window it found, not the other way around. The fit is real. The inference of intent is the part we add, which leaves the question exactly where it should be left, sharp and unresolved. The universe is tuned with a precision that demands an explanation, and the precision alone refuses to name which explanation is right. So if we can't crack it by asking why the numbers are what they are, there's one move left. Stop asking about the values on the dials. Start asking what the dials are made of. What a law of physics actually is underneath. And a small number of physicists chasing exactly that question, arrived at an answer that sounds insane until you follow the steps. That underneath the particles and the forces and the finely tuned constants, the universe might not be made of matter at all. It might be made of information. A bit is the smallest possible piece of knowing. One yes or no, one this, not that. For most of the 20th century, physicists treated bits as bookkeeping, a convenient way to describe the world. One man spent the last decades of his life arguing they were the world, that matter and energy and space were the bookkeeping, and information was the thing being kept. He may have been wrong. He was wrong in a way that turned out to be productive, which is the most interesting way to be wrong. His name was John Wheeler, and he had a habit of naming things before anyone else understood them. He gave us the term black hole. He coined wormhole. He trained a generation of physicists, including the man who would later invent the quantum computer, a thread we'll pick up before the night is over. And late in his career, he distilled his strangest conviction into 3 words. It from bit. Every it, every particle, every field, every force, draws its existence from bits, from answers to yes or no questions posed by acts of measurement. To understand why a serious physicist would say something that sounds like mysticism, you have to look at the experiment that haunted him and look at it more carefully than the popular version allows. Send light through 2 narrow slits onto a screen behind them. You get stripes, bright bands, dark bands, the unmistakable signature of waves, where crests reinforce and crests cancel. Ordinary wave behavior, known for 2 centuries. Now turn the light source down until it emits 1 particle at a time. 1 photon, then a long pause, then another. Each photon lands as a single dot, a single particle striking 1 spot on the screen. But let the dots accumulate over hours, thousands of lone particles, each arriving with no companions to interfere with. The stripes come back. Each photon went through the apparatus alone. There was nothing else there to wave against. And yet the pattern that builds up is the pattern of waves passing through both slits at once. Each solitary particle behaves as though it explored both paths and interfered with itself. Now the part that the documentaries usually mangle. Try to catch the photon in the act. Put a detector at 1 slit to record which way each particle went. The stripes vanish. You get 2 plain blobs, exactly what you'd expect from particles fired through 2 holes. The standard telling says the photon knows it's being watched, that consciousness collapses the pattern. That telling is wrong, and the truth is stranger and cleaner. The pattern doesn't depend on whether a mind looks at the detector. It depends on whether the information about which path the photon took exists anywhere in the universe at all. Record that information, even into a machine no human ever reads, even into a single atom that gets nudged as the photon passes and the interference dies. Arrange things so the which path information is never created or is scrambled beyond any possible recovery, and the stripes return. Not the watching, but the record, the existence of the answer to the question which slit. Think of it like footprints. Cross a stretch of wet sand and you leave a trail, recoverable, a record of where you stepped. Cross a slab of bare rock and the path leaves no trace, no recoverable fact about which way you came. In the quantum experiment, when the photon's path is written into the world like footprints in sand, it behaves like a particle that took 1 route. When the path leaves no recoverable mark, like steps across rock, it behaves like a wave that took both. What decides the photon's nature is not a watcher. It's whether reality is holding a record. This is the fact that pushed Wheeler off the edge, because it makes information sound less like a description of what particles do and more like a switch that determines what they are. The presence or absence of one bit, which slit, yes or no, changes the physical behavior of the particle. Not our knowledge of the behavior, but the behavior itself. Wheeler took that and ran further than the evidence strictly allows, and it's worth being clear about where the solid ground ends. He proposed that reality itself is built this way from the bottom up, is less than #0. 5# is greater than that. Nothing is fully real until a question has been asked and answered, until a measurement has forced a definite bit into existence out of a haze of possibility. The universe, in his picture, is a vast self-assembling answer to its own questions, with existence accumulating one resolved bit at a time. When pressed on whether this meant the world only became definite when looked at, he didn't flinch from the implication. No one ever built a working theory of physics out of it from bit. You cannot calculate anything with it. It predicts no number you could check. By the standards physics uses to keep itself honest, it failed. Wheeler knew this. He pursued it anyway, because he was chasing something underneath the equations, and even chasing it, he left a kernel that refused to go away. The kernel is this: whether or not information is the foundation of reality, it is unmistakably physical. A bit is not an abstraction floating free of the world. Where the which path information is stored, in sand or in an atom, has physical consequences you can measure on a screen. Information leaves marks, occupies systems, changes outcomes. Energy, momentum, the state of a particle, every quantity in physics can be rewritten in the language of bits, information shuttling under strict rules. The skeptics of Wheeler's day called that poetry. They asked how something as bloodless as a choice between 0 and 1 could give rise to the weight of a mountain or the heat of a star. It's a fair challenge, and it has an answer, and the answer is what turns this from philosophy into physics. If information is just an abstraction, just our description of things, then erasing it should cost nothing. Deleting a thought, clearing a memory, resetting a bit from 1 to 0 ought to be free. Pure bookkeeping has no price. But if information is physical, truly physical, then destroying it should cost something real. Energy, heat. A tax the universe collects whenever a bit is wiped away. A measurable, do-it-in-the-lab test. Either forgetting is free, and Wheeler was a poet, or forgetting has a temperature, and information is as real as iron. I find it remarkable that a question this philosophical, what is reality made of, comes down to something this concrete. Does erasing a single bit warm the room by even the faintest amount? A physicist, working not on the cosmos but on the limits of a machine, asked exactly that. And the answer he found is the first hard evidence in this entire story that the universe might, at its root, be running on information. In 1961, a physicist at IBM went looking for the cheapest possible computer and accidentally found a law of the universe. His name was Rolf Landauer, and he was not chasing the nature of reality. He was chasing waste heat. IBM's room-sized machines ran hot, and Landauer wanted to know the floor. Was there a minimum amount of energy it takes to process one piece of information? A hard limit no engineering could ever beat? A practical question, asked by a practical man, about a machine. What he found was that the cost depends entirely on what you do with the information. And the answer split computation into two kinds, with a line between them that turns out to run straight through the foundations of physics. Most operations a computer performs are, in principle, free. You can add, copy, flip, route, all of it, using as little energy as you like, if you're careful enough. There's no fundamental tax on those, because every one of them can be undone. Run them backward, and you recover exactly what you started with. Reversible operations carry no thermodynamic price. But one operation is different, and it's the one we think of as the most innocent. Erasing. Taking a bit that might be a 1 or a 0 and forcing it to 0, no matter what it was. That you cannot undo. Once a bit is erased, the information about its former value is gone, and nothing run backward can tell you what it used to be. Erasure destroys a distinction, and destroying a distinction, Landauer showed, is never free. Here's the mechanism, stated plainly, because it's cleaner than any metaphor. Before erasure, a bit has two possible states. It occupies, in a sense, twice as much room in the space of possibilities as it will afterward. Erasing it collapses those two possibilities into one. The number of states the system can be in is cut in half. A reduction in the spread of possibilities is, precisely, a reduction in entropy. And the second law of thermodynamics forbids entropy from simply vanishing. If it drops in one place, it must rise somewhere else by at least as much. So, when you erase a bit, the entropy you removed from the information has to be paid out into the surroundings, and the currency it's paid in is heat. The amount is fixed by the temperature, and it is staggeringly small. At room temperature, erasing a single bit releases about 3/trillionths of a trillionth of a joule. A number that means nothing until you scale it, so here it is. To warm a single teaspoon of water by 1 degree, you would have to erase roughly 7 sextillion bits. 7 followed by 21 zeros. The heat from forgetting one thing is so faint that all the forgetting in all the world's computers barely registers against it. But faint is not zero, and zero is the whole point. Landauer had found that information is not a ghost riding on top of physics, is less than #0. 5# is greater than erasing. It has a temperature. Forgetting warms the world by an amount the universe itself sets that no cleverness can ever reduce to nothing. A bit is as physical as a stone, because deleting it, like crushing a stone, releases heat into the room. For decades, this sat as a curiosity about computers. Then it solved a paradox that had tormented physics for nearly a century, and this is where the idea earns its place in this story. Back in 1867, a thought experiment seemed to break the second law of thermodynamics entirely. Imagine a tiny, intelligent being guarding a door between two halves of a gas-filled box is less than #0. 5# is greater than. It watches the molecules, and whenever a fast one approaches from the right, it opens the door to let it left. Whenever a slow one comes from the left, it lets it right. Slowly, without spending any obvious energy, it sorts the gas into a hot side and a cold side. It creates order from disorder, lowers entropy for free. A machine that runs on pure information, quietly violating the deepest law in physics. For 100 years, no one could fully say what was wrong with it. The being seemed to cheat the universe using nothing but knowledge of which molecule was which. Landauer's principle, completed by a colleague named Charles Bennett, finally closed the trap. The being has to remember which molecules it sorted, its memory is finite. Sooner or later, it must erase old observations to make room for new ones. And erasing those bits, by Landauer's law, dumps exactly enough heat back into the world to cover the entropy it thought it had stolen. The debt always comes due. It just hides inside the act of forgetting. That resolution is, to me, one of the most beautiful turns in physics. The second law was never threatened by a creature that knows things. It was rescued by the physical cost of unknowing them. Information was the missing term in the universe's books all along, and once you count it, the ledger balances perfectly. Knowledge can buy you order. Forgetting is when you pay. And in 2012, this stopped being theory. A group trapped a single microscopic particle in a tiny double-welled landscape, one well for 0, one for 1, and erased its state while measuring the heat released. The energy came out right at Landauer's floor, not a fraction less. The universe charges exactly the predicted price to forget one bit, and now we've watched it collect. If erasing information has a physical cost, then information is a physical thing is less than #0. 5# is greater than. If information is physical, then every event that changes information, every photon striking your eye and registering a bit, every electron settling into a new state, every chemical bond locking into place, is moving information around under physical rules. And moving information around under rules is, more or less, the definition of computation. Which makes it tempting to say the universe is not a thing that happens to carry data. The universe is data, churning. Landauer proved that information has a thermodynamic cost, that is, rock. The jump from there to the universe is fundamentally computation is interpretation, not proof, and a lot of careful physicists stop at the rock. But the rock alone is remarkable enough. Wheeler guessed that information was real and got laughed at. Landauer, asking about heat in a mainframe, proved the kernel of the guess was right. Bring it down to the thing sitting between your ears. Every memory you've lost tonight, every detail of this afternoon already slipping away, was not erased for free. Your brain runs far hotter than Landauer's limit, wildly inefficient compared to that perfect floor. But the principle holds in your skull as surely as in any chip. Forgetting is a physical act with a physical cost, and the warmth of your own head is, in some unmeasurably small part, the price of everything you've let go of. So, information has weight in the world. We've established that much on solid ground. The next question is whether it goes deeper still. Not just that information costs something, but that it might be the reason the universe comes in pieces at all. Why energy arrives in packets, why matter is grainy, why nature, at its base, refuses to be smooth. Whether the universe is quantized because information itself can only come one bit at a time. Why does the universe come in pieces? Light arrives in packets, energy climbs in steps. Matter is built from indivisible bricks. Nothing in the world is smooth at the bottom, and for over a century we accepted that as a brute fact, fitted to the data and never explained. One physicist in Vienna proposed that the graininess of reality and the graininess of information are the same graininess. If he's right, the universe is built from bits not as a metaphor, but as an architecture. The puzzle goes back to 1900. Physics had assumed energy could be divided as finely as you liked, poured like water. Then, forced by an experiment that classical theory got catastrophically wrong, came the discovery that energy only comes in discrete amounts, minimum chunks, quanta. A heated object can emit a certain packet of energy, or 2 packets, but never 1.5. The world, examined closely enough, is pixelated in energy. That discovery built the 20th century, and it left the deepest question unanswered. Not how the packets behave, which we mapped exquisitely. Why packets at all? Why should nature, which looks so continuous to us, refuse smoothness at its foundation, is less than has Hone? 5 hash is greater than. For most of physics, that was simply how things are, a rule with no reason beneath it. Anton Zeilinger spent his life in the laboratory taking quantum systems apart to their simplest possible form, and around the turn of the millennium he turned that experimental instinct toward the why. His starting point was almost embarrassingly simple. Take the smallest quantum system there is. The spin of a single electron, say, or the polarization of a single photon. Ask it a question. Is the spin up or down along this direction? You get exactly one answer, up or down, 1 bit. You do not get a little bit up and a little bit down. You do not get a reading of 60%. You get one of 2 outcomes, full stop, every single time, no matter how refined your instrument. The answer space itself has only 2 points in it. Not because we lack a finer ruler, but because there is nothing finer to measure. A single elementary system can hold the answer to one yes or no question, and not one fraction of a question more. Zeilinger's proposal was to take that not as an accident, but as the foundation. What if an elementary system carries exactly 1 bit because 1 bit is the most reality stores at that level? Then the discreteness everyone had puzzled over for a century isn't a strange property of energy. It's the discreteness of information showing through. Nature comes in packets because a bit is the smallest unit of truth there is, and you cannot have half an answer to a yes or no question. Watch how much this would explain if it held. Why measurements give definite, discrete outcomes? Because each one extracts a finite number of bits. Why a quantum system can sit in superposition before measurement? Undecided. Because the bit hasn't been fixed yet, the question hasn't been answered. Why the world is grainy? Because information is grainy, and the world is information wearing the costume of matter. The quantization that physics had simply accepted would become a consequence, deduced from something deeper. I have to be honest about the standing of this idea. This is a research program, not a settled result. Zeilinger, and others after him, have tried to rebuild the entire framework of quantum mechanics, starting from principles about information, and they've made real progress, deriving real features of the theory from informational axioms. Is less than has Hone. 5 hash is greater than, but it is one route among several, and most physicists do not yet say the universe is made of information the way they say it's made of atoms. It's a candidate for the bottom. A serious, mathematically developed candidate, but not a verdict. What is not in doubt is the experimental reality Zeilinger built his career on, and it makes information feel more fundamental than any argument could. Take 2 particles and entangle them. Now the strange part. Neither particle, on its own, carries a definite answer to anything. The information doesn't live in particle 1, and it doesn't live in particle 2. It lives in the relationship between them, distributed across the pair, belonging to neither alone. Measure one, and the other's answer is fixed instantly, even if they're separated by the width of a continent. This was tested, rigorously, against every loophole skeptics could raise, and the verdict held, which is the work Zeilinger was given the Nobel Prize for in 2022. The information in an entangled pair is real, and it is not stored in the things is less than #. 5# is greater than. It is stored in the correlations, in the structure connecting them, which is precisely what you'd expect if the structure, the information, were the primary thing and the particles were secondary, mere addresses where bits happen to be read out. So stand back and see what we've assembled, because this is the moment the whole video has been building toward. Information has a physical cost. Landauer proved it. Information may be the reason reality is quantized. Zeilinger's program argues it. Information lives in relationships, not objects. Entanglement experiments confirm it. Piece by piece, the picture of a universe made of matter is being replaced at the foundations by a picture of a universe made of bits under rules. And the instant you say that out loud, a door swings open that cannot be shut again. Because anything made of bits under rules has a name in our world. We call it computable. A system that is fundamentally information processed according to fixed rules is, by definition, the kind of thing a computer could run. And if our universe is computable, then nothing in principle stops a sufficiently powerful machine, somewhere, from running it. This is the hinge of the entire simulation argument, and I want to show you both the force of it and the crack in it, because they sit right next to each other. The force is real. We have spent 7 acts watching reality behave more and more like information under computation, and we have, in our own small way, already started computing pieces of universes ourselves. If the cosmos is software, the question stops being absurd and becomes a matter of resources and time. Computable does not mean computed. That a thing could in principle be run as a program is a statement about its logical structure. It says nothing, by itself, about whether anyone is running it or whether it needs to be run at all to exist. A melody can be written as notes on a page. That doesn't mean every melody you've ever heard was read off a page by someone. The universe being describable as computation, and the universe being a computation someone built, are two different claims, and the leap from the first to the second is exactly where the trouble lives. We'll spend the rest of the night on that leap, because one philosopher took it seriously enough to turn it into an argument with a disturbing conclusion. He didn't claim we're simulated. He claimed something stranger. That if you accept a few reasonable-sounding premises, you're forced to conclude that almost certainly we are. Or else something is waiting for us that's worse. In 2003, a philosopher published an argument that does something arguments almost never do. It doesn't try to convince you that we live in a simulation. It tries to convince you that you must believe one of 3 things, and that all 3 are deeply uncomfortable, and that there is no 4th option. The trap is in the structure. Once you're inside it, every exit costs you something. His name is Nick Bostrom, and the cleanest way to feel the force of his reasoning is to build it the way he did, one premise at a time, watching for the floorboards that creak. Begin with a single assumption, and notice it as you accept it, because it carries more weight than anything else in the argument. Assume that consciousness does not require biological flesh, that a mind is a pattern of information processing, and that if you reproduce that pattern faithfully enough in silicon, in any medium at all, the lights would come on inside it. A simulated person, run in enough detail, would not just act conscious. They would be conscious, with an inner life as real to them as yours is to you. Assume civilizations tend to get better at computing over time, as ours has, relentlessly, for a single human lifetime so far. Project that forward, not a year, but 10,000, 100,000. Eventually, a civilization could build machines powerful enough to run simulated worlds containing simulated minds, fully conscious, entirely unaware they are running inside a machine. And once that's possible, the numbers turn savage. Roughly 100 billion humans have ever lived across 200,000 years of biological existence. A single civilization that wanted to could simulate that entire history and run it again and again, 1,000 times, 1,000,000 times, on hardware that fits in a room. The biological minds are a one-time event, bounded by the slow grind of birth and death. The simulated minds could be churned out by the trillion, on demand, forever. So if conscious simulated minds are possible at all, then across all of space and time, the simulated would outnumber the biological not by a little, but overwhelmingly, drowning them. And now the blade. If almost every conscious being who ever exists is simulated, then a being selected at random is almost certainly one of the simulated ones. You did not choose to be you. You simply found yourself being someone. And if you treat yourself as a typical example, a random draw from the pool of all minds, the math says you are far more likely to be one of the trillions of simulated minds than one of the rare biological originals. That's the conclusion that gets quoted. We are probably simulated. But Bostrom's actual argument is sharper and more honest than that, and it's worth holding the real version, not the headline. He never claims we are simulated. He claims that at least one of three statements has to be true. First, almost no civilization survives long enough to reach the technology to do this. Something kills them all before they get there, every time, with brutal reliability. Second, civilizations do reach that power, but almost none of them ever bother running these simulations, across all of them, with near-perfect consistency. Third, we are almost certainly living in a simulation right now. Those are the only three doors, and that's what makes the argument so hard to shake. Because look at what it costs to walk out through the first two. Deny the third, insist we are real, and you've committed yourself to door 1 or door 2. Door 2 asks you to believe that essentially every advanced civilization that could ever exist will decline to simulate, unanimously, forever, which is a strange bet against curiosity. And door 1 is darker. Door 1 says civilizations don't reach that level because they destroy themselves first. Which means a confident we are definitely not in a simulation quietly implies we are probably not going to make it. That's the cruelty of the structure. The optimistic-sounding belief that we live in base reality, the real thing, leans toward a future where our species ends young. The belief that lets us imagine a long future, a civilization that survives and matures, pushes us toward concluding we're probably already inside someone else's machine. Bostrom didn't smuggle the doom in. It falls out of the logic on its own. So is the argument right? The whole thing rests on that first assumption, the one we noticed accepting. Substrate independence. The claim that a faithful simulation of a mind is conscious. We do not know that. We have no idea, actually, whether running the right computation conjures an inner experience or just produces a very convincing puppet with no one home. If simulated minds can act conscious without being conscious, the population of real experiencers never explodes, and the whole probability collapse never happens. Then there's the move that does the heaviest lifting, treating yourself as a random sample from all minds. It sounds innocent. It is not. To say you are a typical observer, you have to decide what pool you're being sampled from, and that choice is arbitrary in a way nobody has solved. Are you a random human? A random conscious being? A random mind capable of asking this question? Each choice gives a different answer, and there's no principled way to pick. The argument needs you to be a fair coin drawn from a well-defined bag, and no one can say what's in the bag. To compute the odds that we're simulated, you'd need to know how many simulations exist, run by how many civilizations, with what frequency. We have not a single data point for any of these. 0 confirmed simulations. 0 confirmed civilizations besides our own. The argument performs probability with no probabilities in hand, which is less a calculation than a feeling dressed in the clothing of one. So here's the metaphor that holds the whole thing for me, and its limits. Picture a room with one real window looking out on a real street and a million screens on the walls, each playing a perfect recording of that same street. Point at one surface at random, and yes, you'll almost certainly point at a screen, not the window. The logic is airtight. But it only works if you already know the million screens exist. Walk into a room with one window and no screens, and the same reasoning would have you doubting the window for nothing. Bostrom's argument tells you what to conclude if the screens are real. It cannot tell you whether anyone ever built a single one. That's the honest shape of it. Not a proof that we're simulated, but a proof that we can't comfortably believe we're not without accepting something equally unsettling about our future. A logical structure with real teeth and no data in its mouth. Which means the entire argument hangs on one unanswered question, and it's a question we, uniquely, are now in a position to start answering. Everything depends on whether conscious minds can be built out of computation. Bostrom assumed it. We are, right now, for the first time in history, actually trying to do it. Building minds, or things that look unnervingly like minds, out of nothing but numbers and rules. How close are we, really, to making a mind that doesn't know what it is? For all of history, fluent language meant a mind behind it. If something spoke to you in sentences, reasoned, answered, changed its mind, you knew, without checking, that someone was home. That assumption held for every conversation any human ever had. In 2017, a research paper quietly broke it, and most people didn't notice until the thing was already talking back. Attention is all you need. A team at Google described a new way to build a language system, and the architecture they introduced, the transformer, became the engine under nearly every machine that now writes, answers, and converses. What it does is worth understanding precisely, because the precise version is far stranger than the headlines and far more relevant to the question we're carrying. Strip away the engineering and the core idea is almost embarrassingly mechanical. The system reads text as a sequence of fragments, words, and pieces of words. For each fragment, it asks a single repeated question. Of all the other fragments around me, which ones matter for what I mean, and how much? Every word, in effect, casts a weighted vote on every other word. The word bank votes strongly on river if the sentence is about water, and strongly on money if it's about loans. Meaning isn't stored in any single place. It emerges from the entire pattern of votes, recomputed for every word, layered over and over. That voting process is what the paper called attention, and the name is a small act of seduction worth flagging. It is not attention in any sense you'd recognize from your own mind. There is no awareness in it, no focus felt from the inside. It is a weighted sum, a routing of numbers according to learned relevance. But we called it attention, and the word carries a stowaway, the quiet suggestion that something is paying attention. The metaphor arrived before anyone could prove it deserved to. Here's how the system learns those weights, and this is where it diverges sharply from anything biological. You feed it staggering quantities of human text and give it one task: predict the next fragment. Given everything so far, what word comes next? Do that billions of times, adjusting the connection strengths each time it guesses wrong, and slowly the pattern of weights settles into something that captures the statistical shape of language itself, is less than has hone. 5# is greater than, not the meaning, in any sense we can verify, but the structure. Which words follow which? In which contexts? Across the whole written output of our species. And from nothing but that, prediction of the next word, refined at enormous scale, comes something that argues, explains, jokes, and reasons through problems. Behavior we have never once, in all of history, seen arise from anything but a conscious mind. Produced by a system we can describe completely, down to the last multiplication. Now the differences from a brain, because they ought to be sharp, and they are not in dispute. Your brain learns continuously. Rewiring itself with every experience is less than #0. 5# is greater than. These systems learn once, in training, and then their connections freeze. During a conversation, nothing is being learned. The weights are fixed. Your understanding is grounded in a body, in sight and touch and consequence. Theirs is grounded in text about a world they have never touched. Your neurons fire in time, in sequence, electrochemical and slow. The transformer processes a whole passage at once, in parallel, in pure arithmetic. These are not small differences. They are the kind that should make you cautious about every word of comparison. So does it understand? Does it think? And here I have to be careful, because the honest answer is that the question is broken, not unanswered. We never had a real test for understanding. We had a proxy. If it talks like it understands, it understands. That proxy worked flawlessly for thousands of years because the only things that talked like they understood were people. The transformer kicked the proxy out from under us. Now we have a thing that passes the only test we ever had, and we no longer trust the test, and we have nothing to replace it with. A philosopher saw this coming, decades early, with a thought experiment worth holding up against the machine. Imagine a person locked in a room, who speaks no Chinese, handed an enormous rule book. Slips of paper with Chinese characters come under the door. The person looks up each pattern in the rule book, copies out the response it dictates, and passes it back. To everyone outside, the room answers fluent Chinese. Inside, there is no understanding at all. Just a person matching symbols to rules, comprehending none of it. So where, the philosopher asked, is the understanding? Not in the person and not in the book, nowhere. That argument has been fought over for 40 years. Plenty of thinkers answer that the room as a whole understands, even if no part does, the way no single neuron in your head understands English, yet you do. The point isn't who wins. The point is that we built the Chinese room. It's running now, and we cannot tell, from the outside, whether there's understanding in it or only the rulebook executing. And this is exactly the assumption that Bostrom's entire argument was hanging on. Remember the load-bearing premise from before, that a faithful enough computation of a mind would be conscious, would have someone home, rather than being a perfect puppet with no inner light. We could treat that as abstract speculation, last act. We can't anymore. We have built systems that behave like minds, and we have no method, none, to determine whether anything is experienced inside them. The puppet with no one home and the actually aware mind would, from where we stand, look identical. That's the discovery that should unsettle you more than any pixel or speed limit. The unsettling part isn't that machines might be conscious, is less than #0. 5 hash is greater than. It's that we have lost the ability to tell the difference, and we may have lost it permanently, because the only instrument we ever had for detecting other minds was their behavior, and behavior can now be manufactured without us knowing what, if anything, lies behind it. Bring it to the words in front of you right now. As you read this, your brain is doing something, and that something is accompanied by experience. There is something it is like to be you, reading. A machine could generate sentences much like these, and we cannot say whether anything accompanies that generation at all. Same output. Possibly an abyss of difference underneath, or possibly none. And the thing that haunts me is that you only know your own side of it. You know there's experience behind your reading because you're living it. You have never had access to the inside of any other mind, human or otherwise. You infer it, always, from the outside, from behavior. Which turns the question back on us, hard, and this is where the next act has to go. If a system can produce every outward sign of a thinking, choosing mind while running on nothing but fixed rules and weighted sums, and if we, too, are physical systems, neurons firing under the laws we've spent this whole video uncovering, then what exactly is the difference between us and the rulebook? When you make a choice tonight, a real choice, freely, is anyone actually choosing? You're going to decide, sometime soon, whether to keep listening or to sleep. It will feel like a choice. It will feel like yours. The question this act asks is whether that feeling corresponds to anything real or whether it's the most convincing illusion the universe produces. Start with the bleakest version, the one physics handed us 3 centuries ago and never fully took back. If the world is made of particles obeying fixed laws, then the state of everything right now determines the state of everything next. Every atom in your brain is somewhere, moving somehow, and the laws say exactly where it goes. Your next thought is already encoded in the present arrangement of your neurons. The way the next frame of a film is already on the reel is less than #. 5 hash is greater than. A mind powerful enough to know every particle could read your entire future off the present, including this sentence, including your decision about sleep, made long before you feel yourself making it. That's classical determinism, and it's airless. In that universe, the feeling of choosing is a kind of weather, real as a sensation, empty as a cause. You don't author your decisions. You witness them arriving, narrated by a self that takes credit for what the atoms were always going to do. For 200 years, the best physics we had pointed straight at this conclusion, and people mostly looked away from it. Then quantum mechanics arrived and broke the clockwork, and a lot of people grabbed the broken piece and held it up like a rescue. Here's what actually broke, stated carefully. At the quantum level, outcomes are not fixed by the present state. When a particle's path resolves, which way it goes is, as far as we can tell, undetermined until it happens, as far as anyone can tell, is less than #. 5# is greater than. It is not hidden from us and not secretly predetermined by variables we can't see. A deep result called Bell's theorem closes off most of the ways the randomness could be fake determinism wearing a mask. The dice are real. The future, at the smallest scale, is not written in the present. So the universe contains true randomness. The real isn't fully exposed. And the temptation is immediate and overwhelming. If the future isn't fixed, then maybe free will lives in the gap. Maybe in the quantum flicker, the soul finds room to push. I understand the pull of that. I also think it's a mistake, and the mistake is instructive. Because random is not free. That's the hinge of the whole problem. If your decision to sleep was determined by clockwork, it wasn't yours, it was the atom's. But if your decision was determined by a quantum coin flip, it still wasn't yours, it was the coin's. A choice made by dice is no more authored by you than a choice made by gears. Swapping determinism for randomness doesn't deliver freedom. It just changes who's not in control, from the laws of motion to pure chance. Free will seems to need something that is neither determined nor random. Not forced by the past, but not arbitrary either. A decision that flows from you, your reasons, your character, while still being, in some sense, up to you. But physics offers only two boxes, caused or chance, gears or dice. There is no third box on the shelf. And free will, as we usually imagine it, fits in neither. It gets worse for the quantum rescue story, on purely physical grounds, and this detail is decisive. For quantum randomness to influence your choices, those tiny undetermined events would have to survive long enough to nudge a neuron. They can't. Your brain is warm and wet, about 310 degrees on the absolute scale, packed with jostling molecules. In an environment like that, a delicate quantum superposition collapses almost instantly in a tiny fraction of a second, far faster than a neuron takes to fire, is less than #. 5# is greater than. The quantum flicker is real, but it gets washed out by the heat long before it could reach the scale where thoughts happen. By the time you're deciding anything, the dice have already averaged into ordinary, lawful behavior. So the gap people hope to hide free will inside is, for the brain, almost certainly sealed by physics itself. Which leaves the question looking unanswerable, except there's a way out that doesn't require winning this fight at all. What if the dichotomy is the error? What if free will was never about being uncaused? Consider what you actually mean when you say a choice was free. You don't mean it came from nowhere. You mean it came from you, from your reasoning, your values, your weighing of options, rather than from a gun to your head or a drug in your veins or someone else's hand? On this reading, a free choice isn't an uncaused one. It's one caused in the right way, by the self doing the deciding. And that kind of freedom is perfectly compatible with being a physical system, because the physical system, running its reasoning, is the you that does the choosing. Now ask the question we've been building toward. If we're a simulation, are we less free? And the answer, suddenly, is no, for a reason that should feel solid by now. Whether your reasoning runs on neurons or on silicon, it's still your reasoning doing the work. The substrate doesn't touch the question, is less than has own. 5# is greater than. A simulated mind weighing its options, choosing by its own values, is exactly as free, or as unfree, as a biological one. The free will problem doesn't get worse if we're computed. It's the identical problem on different hardware. When we build complex simulations, we often feed them a stream of true randomness, a random number generator, to keep the simulated world from locking into a dead, repeating loop. Our universe has exactly such a stream built in. The quantum flicker, the real dice, the undetermined outcomes at the smallest scale. If something is running this, it didn't write our every moment in advance. It left the randomness live, unresolved, computed only as it happens. Which means even in the bleakest reading, where we are someone's program, we would be a program whose future is not yet stored anywhere, not even in the machine. I find a strange, quiet comfort in that. The dice don't choose for you any more than the gears do. But it means the next frame of your life is not sitting finished on some reel, waiting. Determined or not, authored or not, it has not happened yet. And in a universe with real randomness at its root, it could not have been fully written until it does. So your decision about sleep is still coming, still unwritten, whatever it turns out to mean to call it yours. But all of this freedom, or whatever it is, hangs on that quantum randomness being real, being irreducible, being the real churn at the base of things. And that same churn, the superposition, the entanglement, the refusal to hold still, is the single hardest thing in the universe to simulate. So hard that it nearly rules out the whole idea of computing a universe at all. Unless the machine running it were built from the very stuff it was trying to reproduce. We can simulate a galaxy. We cannot simulate a snowflake's worth of atoms. Not approximately, not with a bigger budget, not ever, with the kind of computers nearly all of us use. The reason is a wall built into the structure of the quantum world, and once you see its shape, the impossibility we found in the first act looks almost gentle by comparison. Start with something you can count. A classical bit is a 0 or a 1. To describe the state of one bit, you write down one number. 10 bits, 10 numbers. 1,000 bits, 1,000 numbers. The cost of describing a classical system grows in step with its size, one for one, politely. This is the world our computers were built for, and it scales the way intuition expects. Twice the system, twice the bookkeeping. Now make the bits quantum and watch the politeness collapse. A single quantum bit is not just 0 or 1. It exists in a superposition, a weighted blend of both at once, and to capture that blend you need not one number but two, the amount of 0 and the amount of 1 mixed together. Fine, you think. 2 numbers instead of 1. Manageable. But add a second quantum bit, and the system is now in a superposition of 4 possibilities at once. 0 to 0, 0 to 1, 1 to 0, 1 to 1, each with its own weight. 4 numbers. 3 quantum bits, 8 numbers. 4, 16. Every single bit you add doubles the count. Doubling sounds harmless until you let it run. 10 quantum bits already need about 1,000 numbers to describe. 20 need 1,000,000. 50 need a quadrillion. And at 300 quantum bits, the number of values you'd need to write down to capture the state exceeds the number of atoms in the entire observable universe. Read that again, because it's one of the most staggering facts in all of physics. 300 particles, a speck of matter you couldn't see without a microscope, can occupy a quantum state so rich that describing it fully would require more numbers than there are atoms in the cosmos. You could grind every particle in the universe into a hard drive, and you still could not write down the state of 300 entangled quantum bits. We said the observable universe holds about 10 to the 122nd bits of information. That was the classical count. The bookkeeping for everything, treated as definite. But the full quantum description, the one that includes every superposition, every entanglement, every blend of possibilities held at once, overflows that number almost instantly for the tiniest scrap of matter. The universe doesn't have one information content. It has a classical one, vast but finite, and a quantum one that explodes past all counting for even a fleck of dust. What makes this irreducible, and not just a failure of clever compression, is entanglement. Recall the lesson from the experiments in Vienna. When particles entangle, their information stops living in the individual particles and starts living in the relationships between them. You cannot describe the parts separately and stitch them together later. The whole carries correlations that no list of individual states could ever reproduce. So you can't break the giant state into manageable pieces and handle them one at a time. The quantum system resists being taken apart, and that resistance is the wall. Picture it with coins, and then let the picture break, because the breaking is the point. Set 100 ordinary coins on a table. To record the arrangement, you note each coin, heads or tails, 100 entries. Add a coin, add an entry. Linear, calm. Now imagine the coins are quantum and entangled, so that no coin has a definite face on its own, and every coin's state is bound up with every other's. Now the table is in a superposition of all 2 to the 100 arrangements at once, and to describe it you'd need to track every one of those arrangements simultaneously. The coins haven't gotten heavier. The thing you must hold in mind to describe them has outgrown the room, then the building, then the planet, then the sky. This is the wall Feynman ran into at the close of a lecture in 1981, and his frustration with it became one of the most quoted moments in modern physics, though I'll spare you the exact words. The substance was this: nature is not classical. If you want to simulate nature, you cannot do it on a classical machine, because the classical machine drowns the instant it touches a real quantum system. A handful of interacting electrons, the kind of thing nature handles in a chemical bond 1 billion times a second, lies forever beyond the reach of the computers we built. And here is the inversion that I find beautiful, the one the source of all our intuitions gets backward. The galaxy is easy because it's classical at the scale we model it. Smooth fields, averages, quantities that add up politely. The speck of dust is impossible because it's quantum, and quantum systems hide an exponential ocean inside even the smallest volume. Difficulty doesn't track size. It tracks how deeply the quantum nature is exposed. The vast is tractable. The tiny is bottomless. But now the deepest question in this act, the one that turns the whole wall into something stranger. Nature does this effortlessly. 2 electrons meet and settle into a bond, resolving their full entangled quantum state in less time than light crosses an atom, with no computer, no struggle, no overflow. The molecule simply is its state. So either nature is performing a computation that no classical machine could ever match, or, and this is the unsettling alternative, the exponential blow-up isn't in reality at all. It's in our description. The 2 paths lead to opposite worlds. Maybe the universe really does track all those amplitudes, in which case it's a computer of unimaginable power, doing more in a grain of salt than all our machines combined. Or maybe a molecule doesn't store 2 to the 300 numbers anywhere, doesn't compute them, just exists, and the impossible quantity is an artifact of how we, on the outside, are forced to write reality down. The territory might be simple. Only our map explodes. We do not know which. That's not me being coy. It's an open seam in physics, and it bears directly on whether this universe could be a simulation. If the exponential cost is real, then simulating our universe demands a machine more powerful than anything classical physics permits, which strangles Bostrom's argument at the source. If the exponential cost is just our clumsy description, then reality is doing something far cheaper than our equations suggest, and the door to simulation creaks back open. Bring it home, because this lives in your skull right now. The decision about sleep you're still carrying involves neurons, and neurons involve electrons, and even one electron's full quantum state, entangled with its surroundings, already needs a description. No classical computer in this universe could store. The thing weighing whether to keep listening contains, in its physical depths, more quantum description than the entire cosmos could hold classically. You are, at the bottom, doing something every supercomputer on Earth cannot. So the wall stands. Classical machines cannot reach the quantum world, which would close the book on simulating reality, except for one idea that turns the whole problem inside out. If you cannot simulate the quantum world with ordinary bits, then stop using ordinary bits. Build your computer out of the same superposition and entanglement you're trying to capture. Make the machine quantum, and let it speak the universe's native language. The solution to simulating the quantum world had been sitting in plain sight, and it was almost insultingly simple once someone said it. If ordinary computers choke on quantum systems because they can't hold all those superpositions, then build a computer that is itself made of superpositions. Don't translate the quantum world into zeros and ones. Speak it directly. The idea crystallized at the close of a lecture in 1981, when Feynman, frustrated by the wall we spent the last act building, told a room of physicists that nature is not classical, and that anyone serious about simulating it had better build their machine out of the same quantum stuff. He saw the problem with total clarity. He did not know how to build the machine. That fell to a younger physicist named David Deutsch, who moved in the same circles, orbiting the same restless mentor who had spent his life insisting reality was made of information. A few years later, Deutsch wrote down what such a machine would actually be, and quantum computing began as a real theory rather than a wish. To see why it works, you have to understand the unit it runs on, and you have to resist the way it's usually explained, because the popular version is wrong in a way that matters. A classical bit is 0 or 1. A quantum bit, a qubit, holds a superposition of both, with a weight on each. String together enough qubits, and they hold a superposition of every possible combination at once, all 2 to the n of them, the exact exponential ocean that drowned the classical computer. But now the ocean isn't a burden. It's the hardware. The qubits don't store the giant quantum state as a list. They are that state, the same way a real molecule simply is its own superposition. People say a quantum computer tries every answer in parallel and reads them all out. It does not. When you finally measure the qubits, you get exactly one result, one combination, collapsed out of the superposition like any quantum measurement. All those parallel possibilities give you nothing if you just look, because looking hands you a single random outcome. The genius is in what you do before you look. The trick is interference, and it's worth feeling the mechanism. Quantum amplitudes aren't just probabilities. They can add and they can cancel, like waves, is less than #0. 5 hash is greater than a skilled quantum algorithm arranges the computation so that the amplitudes leading to wrong answers cancel each other out destructively, while the amplitudes leading to the right answer reinforce and grow. By the time you measure, the wrong paths have erased themselves and the right one stands tall, so the single outcome you read is, with high probability, the answer you wanted. Not parallel search, but choreographed cancellation. Picture searching for one book in an immense pitch-dark library. The classical way is to walk the aisles, shelf by shelf, until you find it. The quantum way is stranger. You send a pulse through the entire library at once, but you tune it so that the echoes returning from every empty aisle arrive out of step and silence each other, while the echo from the aisle holding your book arrives in step with itself, building, amplifying, until it rings out clear above the silence. You never hear what's on the other shelves. You hear only which aisle rang. That ringing, that constructive buildup of the right answer against a hush of cancelled wrong ones, is what a quantum computation actually does. Deutsch himself drew a wilder conclusion from this, and I want to mark it clearly as his, not as settled fact. He is a lifelong champion of the many worlds picture, in which every quantum possibility plays out in a separate branching universe. To him, a quantum computer isn't doing clever interference within one world. It's farming out the work across countless parallel universes, and gathering the results is less than #0. 5 hash is greater than. When he asks where the computation happened, he answers, without flinching, in the other worlds. Most physicists accept the power of quantum computers without accepting that story. The mathematics works regardless of which interpretation you believe. But the disagreement itself is telling. We can build the machine and run it, and still argue about where, or in how many worlds, the answer is computed. The real-world versions of these machines are humbling, and it's worth knowing how raw the technology still is. The most powerful quantum computer publicly known holds about 1,100 qubits. That's trillions of times fewer components than the chip in your phone. And it can only function buried inside an elaborate chandelier of cooling, chilled to a hair above absolute zero, colder than the depths of space, because the faintest warmth shakes the qubits out of their delicate superposition before any computation can finish. The decoherence that washes quantum effects out of your warm brain is the same enemy here, fought with brute cold. These machines are small, fragile, and finicky. And on the narrow set of problems they're suited for, they already do what no classical computer ever could. Their most natural use is exactly the one Feynman pointed at. Not breaking codes, though they can threaten that. Their use is simulating quantum systems. A quantum computer can model a molecule, a material, a chemical reaction, by letting its own qubits play out the same superpositions the real system does. It simulates the quantum world by borrowing the quantum world's own machinery. The wall from the last act has a door, and the door is made of the same material as the wall. So does this rescue the simulation hypothesis? Could a vast quantum computer run our whole universe? And here the loop closes back to where this entire video began, in a way I find almost too neat. To simulate the universe classically, you'd need a classical machine larger than the universe, because you can't store more bits than you have particles. The same trap springs shut on the quantum version. A quantum computer can efficiently simulate a quantum system, yes, but only one no larger than itself. To simulate the entire quantum universe, every entangled particle, you would need a quantum computer with at least as many qubits as the universe has degrees of freedom. A quantum machine the size of the cosmos to hold the cosmos. The impossibility didn't go away. It just changed clothes. Quantum computing makes it feasible to simulate pieces of the quantum world, a molecule, a material, a small corner. It does nothing to make the whole thing fit inside a part of itself. Which means any simulation of our universe, quantum or classical, still cannot be a perfect, total particle-by-particle copy. It would have to economize, approximate the unwatched, render only what's required. Whatever could run a universe cannot run all of it at once in full detail. It must cut corners somewhere. And the most natural place to cut, the place our own simulations cut, the place quantum mechanics itself seems to leave conspicuously blank, is everywhere that isn't being measured. A quantum computer gives no answer until it's measured. A particle has no definite path until it's measured. Possibility becomes fact only at the moment of measurement. So what, exactly, is measurement doing? What happens to reality in the instant something looks? A particle in flight, on its way through an experiment, is doing something. The deepest experiment in this video says it may be false, and worse, that you can prove it false by making a choice after the particle has already gone. We met the two-slit experiment earlier and learned the strange rule. When a record of which path the photon took exists anywhere, it behaves like a particle, one route, no interference. When no such record can exist, it behaves like a wave, both routes at once, stripes on the screen. That alone is hard enough. Now Wheeler asked a question that turns it from hard into vertiginous. What if you wait? What if you let the photon enter the apparatus, commit to its journey, travel most of the way to the screen? And only then, at the last possible instant, after it's already inside, you decide whether to set up a which path detector or to let it interfere. The photon is already in flight. Its choice, wave or particle, should have been made at the entrance, before it could know what you'd do. So which does it turn out to be? He proposed this in 1978 as a thought experiment. Decades later, in laboratories with fast enough switches and delicate enough timing, it was actually performed. The answer is the one that should not be possible. The photon's behavior always matches the choice you make at the end. Decide to measure the path, and it has behaved as a particle the whole way through. Decide to let it interfere, and it has behaved as a wave the whole way through. Your choice, made after the photon entered, fixes what the photon was doing before you chose. The tempting reaction is to say the photon reached back in time, changed its own past, sent a signal backward. Resist that. It's the wrong lesson, and it comes from clinging to an assumption that the experiment is specifically designed to break. The assumption is that the photon had a definite nature while in flight, that it was really a wave or really a particle as it traveled, and that your later choice somehow reached in and altered an existing fact. But that's the very thing being disproven. There was no fact to alter. The clean statement, the one that costs you your intuition but saves you from nonsense, is this. While the photon was in flight, there was no answer to the question, which path did it take? Not an answer hidden from you, not an answer the photon kept secret. No answer at all. The property did not exist. It came into existence only when the measurement context was finally fixed, and then the universe supplied a consistent history to go with it. So the photon didn't change its past. It never had the past you assumed. The question, what was it doing before I measured, presupposes a definite something that quantum mechanics flatly denies was there. Reality, in this experiment, declines to commit to a fact until the fact is forced. Some interpretations of quantum mechanics insist the photon does have a definite something in flight, a hidden trajectory, or a branching into worlds where it did each thing. Those pictures avoid the no-fact conclusion at other costs of their own strangeness. What no interpretation can avoid is the experimental result itself, is less than #0. 5# is greater than. The outcome matches the late choice, every time, and the comfortable classical story, where the photon was simply doing one definite thing all along, is dead in all of them. Now Wheeler pushed it to a scale that should stop your breath, and this is the part the setup was building toward. The choice doesn't have to be delayed by nanoseconds. It can be delayed by billions of years. Light from a distant quasar, on its way to us, can pass a massive galaxy whose gravity bends space-time and offers the light two paths around it, left or right, like two slits the size of the cosmos. That light has been traveling for billions of years, since before the Earth existed. And tonight, here, now, we choose how to detect it. We choose whether to ask which way it came, or to let the two paths interfere. And the light conforms to tonight's choice. Which means the property whether it took one path or both around a galaxy billions of years ago was not settled until a creature on a small planet decided, this evening, which question to ask. Not because we reached back through time. There was nothing back there to reach for. The fact didn't exist until the measurement called it into being. We carry an image of history as a finished thing, a fixed reel behind us, complete in every detail whether or not anyone ever looks. The delayed choice experiment says that image is, at the quantum level, simply wrong. The unmeasured past is not a finished reel. It's a set of possibilities still open, waiting for a measurement that may not come for billions of years, and may decide, when it comes, what was true all along. You know the experience of revisiting an old decision and watching its meaning shift, how a choice that seemed like a mistake becomes, in hindsight, the thing that saved you. We treat that as a trick of interpretation, the facts fixed, only our reading of them changing. The quantum world goes further than the metaphor. Down there, it isn't only the meaning of the past that stays open. It's the fact itself. We've watched the universe refuse to commit to more precision than measurement demands, in the weather. We've watched it economize, in our own simulations. We've watched any possible cosmic simulation forced to render only part of itself from the impossibility proofs. And now we watch reality itself decline to fix a fact until something measures it. A universe that doesn't decide which path a photon took until forced to look is behaving suspiciously, exactly like a system that doesn't compute what no one is observing. That parallel is seductive, and I can feel its pull as strongly as you can. A photon's path left blank until measured looks just like a video game, leaving a room unrendered until the player turns to face it. Save the memory. Compute only the observed. Fill in the rest on demand, consistently, so no one catches the gap. It fits. It fits beautifully. And fitting beautifully is precisely when a mind should grow most suspicious. Because we are about to ask whether render on demand actually explains anything about quantum mechanics, or whether it's just the most flattering metaphor our computer-saturated age has ever told itself, draped over a mystery it doesn't touch. A particle has no definite value until measured. A video game renders no scenery until the player looks. Put those side by side and the conclusion feels almost forced. The universe must be saving memory, computing only what's observed, exactly like a game engine. It's elegant. It's intuitive. It explains the strangest feature of quantum mechanics in one stroke. And I think it's close to empty. Let me first build it as strongly as its defenders do, because a critique is worthless against a straw man. Every game you've ever played cheats, constantly, in ways you never notice. The world behind your character isn't there. The street around the corner isn't computed until you turn. Distant objects are crude shells that sharpen only as you approach. The machine cannot afford to render an entire world at full detail, so it renders only what's in view, fills in the rest the instant you look, and trusts that you'll never catch the seam because you can't see what you're not looking at. Now lay the quantum facts on top. An unmeasured electron has no definite position. The photon's path stays blank until something asks. Reality seems to leave the unobserved undecided, then snap it into focus the moment a measurement arrives. Save the resources, compute the observed. Render the universe on demand. The fit is so clean it feels like a discovery. Here's why I don't believe it. When you look at what quantum mechanics actually says, the analogy doesn't just fail. It points in precisely the wrong direction. The unmeasured electron is not blank. It is not a patch of unrendered nothing waiting to be drawn. It is a wave function, evolving, and that wave function develops in time according to an exact, deterministic equation, whether or not anyone is watching. The electron spreads, interferes with itself, responds to forces, threads through both slits, all of it lawful, all of it unfolding in the dark, with no observer anywhere near. The universe is not skipping the computation of the unobserved. It is tracking the unobserved in full, in every branch of its superposition at once. And recall from earlier just how expensive that is. The full quantum state of even a few hundred particles needs more numbers than there are atoms in the cosmos. An unmeasured system isn't the cheap case. It's the catastrophically expensive one, the exponential ocean, the thing no computer could store. A game engine saves memory by not computing the unseen. Quantum mechanics does the opposite. It keeps every unseen possibility alive and evolving simultaneously. If reality were trying to save resources, the unobserved electron is the last thing it would handle this way. So the analogy inverts the truth. The render-on-demand picture says the universe is lazy where it isn't looking. Quantum mechanics says the universe is most lavish, most computationally extravagant, exactly where no one is looking, and only becomes simple, definite, cheap at the moment of measurement. Measurement isn't the universe finally doing the work. It's the universe collapsing an enormous computation down to a single answer. What about the appearance of collapse, then? Something does happen at measurement. Yes, and it has a name that has nothing to do with rendering or observers in the conscious sense. Decoherence. When a quantum system interacts with its environment, with stray photons, air molecules, the apparatus, the whole vast jostling world, the delicate superposition gets entangled with all of it, spread so thin across so many particles that the interference becomes impossible to recover. The system looks, from the inside, as if it has picked one definite outcome. No mind required, no render call. Just a small system bleeding its quantumness into a large environment. This is the same lesson from the two-slit experiment, sharpened. What fixes the outcome isn't a watcher. It's interaction, entanglement, the existence of a record spread across enough of the world. The conscious observer was always a red herring. And once you see that, the game engine story loses its last foothold, because there's no player, no viewpoint, no rendering camera. There's just physics interacting with physics, and the appearance of definiteness falling out of the math. So what was the render-on-demand idea actually doing, if it explains nothing? The analogy takes a real feature of the universe. Definiteness appears at measurement and renames it in the vocabulary of computers. It does not say what the hardware is. It does not say what render means, physically, or what demand means, or how a measurement would trigger a computation in some underlying machine. It predicts nothing that quantum mechanics didn't already predict. It just relabels the mystery in words that feel modern, and the feeling of familiarity gets mistaken for the feeling of understanding. That's the move at the heart of so much simulation talk. It begins with a true and modest claim. Reality can be described in the language of information and computation. Then it slides, without earning the step, to a far larger one. Therefore, reality is probably a computation someone is running. The first claim is about our description. The second is about the world. And the bridge between them is built out of metaphors that feel explanatory and explain nothing. Think about what an explanation is supposed to do. It's supposed to make a mystery smaller, to ground it in something you understand better. Render on demand does the reverse. It takes the mystery of measurement and hides it behind a new layer, a machine, a renderer, an underlying system, none of which we can see, test, or describe. The mystery isn't solved. It's relocated, one level down, into hardware we've invented to hold it. And the hardware raises every question the original mystery did, plus new ones. You can feel how this would never end. Picture a dark room. Your intuition insists the far wall is still there even though you can't see it. At the quantum level, even that simple there gets complicated. But the simulation answer doesn't clarify the there. It says, the far wall is data, rendered when you look, by a machine. And then you have to ask what the machine is made of, and where it runs, and what renders it. Every answer is another wall in another dark room, with another machine behind it. This is the turn the night takes from here, and it's a colder one than wondering whether we're in a simulation. The colder thought is that simulation may not be the kind of idea that can ever be an answer at all. Not because it's false, but because of its shape. It explains the world by adding a layer behind the world, and that move can be repeated forever without ever touching bottom. The strangest evidence for this came from someone who set out to disprove the simulation hypothesis entirely. He was sure it was nonsense. He decided to prove it by building his own simulation and listing every constraint he'd be forced to impose to make it work. A speed limit on information, a smaller scale, a budget. And somewhere in the middle of his list, he noticed his own universe had every single one. A skeptic decided to kill the simulation hypothesis once and for all, and the way he tried to do it is the most important argument in this entire video. His plan was simple. Build a simulation of a universe yourself. Write down every corner you're forced to cut, every limit you have to impose to make the thing run at all. Then point at the real universe and say, look, it has none of these tells, so it isn't a simulation. A clean reductio. Expose the fingerprints a fake universe would need. Show ours lacks them. Close the case. It went catastrophically wrong, and the wreckage is illuminating. He started listing the constraints, and the first one was forced on him immediately. You cannot let information travel instantly across your simulated universe. If a change in one region could affect any other region with no delay, the simulation would have to update everything everywhere at once, every instant, keeping the entire cosmos perfectly synchronized in a single step. No coherent computation can do that across a large world. Is less than Hasson. 5 hash is greater than. You need a maximum speed at which effects propagate, a finite rate at which one region can influence the next, or the whole structure dissolves into contradiction. So he wrote down Rule 1, a cosmic speed limit on information. And then he looked up at our universe, and there it was. The speed of light, the exact same thing. A hard ceiling on how fast any effect can cross from one place to another, with no exceptions, woven into the deepest laws we have. The constraint he imposed to make a fake universe coherent was already sitting in the real one. He kept going, because surely the next constraint would be the one that distinguished them. You cannot render infinite detail. No machine can store endless decimal places or resolve structure all the way down forever. The memory runs out. So a simulation needs a smallest scale, a floor below which it stops dividing, or a limit on how precisely any quantity can be specified. Rule 2. Finite resolution. Finite precision. He looked up again. Quantum mechanics. The refusal of nature to pin a particle's position and momentum down together past a certain sharpness. The deep suspicion, from quantum gravity, of a smallest meaningful scale. The very precision wall we found hiding behind the weather, where reality seems to run out of decimals to hand over. Rule 2. Already in the real universe. He needed a third. Something to keep the world from freezing into a dead, repeating pattern. A purely deterministic simulation can lock into a static loop, predictable and lifeless. So you feed it a source of real randomness, unpredictable inputs that keep the future open and the world fresh. Rule 3. Lawful evolution, plus a wellspring of true randomness. And there, in our universe, sat quantum indeterminacy, the real dice at the base of things, the unwritten next frame we spoke about earlier. By now, the pattern had turned on him, and he understood the trap he'd walked into. Every single constraint he was forced to impose to make a simulation work, the real universe already had. Not approximately, but exactly the kinds of limits, in exactly the places. The fingerprints he meant to use as proof of artificiality were all over the real thing. His reductio had reduced nothing. It cut both ways, equally, and left him holding an argument that pointed at both answers at once. Now you might hear this and conclude the opposite of what he intended. If the universe has every constraint a simulation would need, doesn't that mean it probably is one? And this is the exact knife edge to walk, so let's walk it slowly. The constraints are consistent with our universe being simulated, completely. They are also completely consistent with it not being. Here is why, and it's the deepest point in this video. Ask what those constraints actually are. A speed limit on information, a floor on detail, a limit on precision. Lawful order with a seam of randomness. Now ask, could any universe capable of holding stable structure, causality, observers, exist without them? A universe with no speed limit, where every event affected everything instantly, would have no separable regions, no local cause and effect, possibly no coherent history at all. A universe with infinite detail at every point would require infinite information in every grain, and we saw in the first act what infinite information does. A universe with no randomness might be locked, sterile, unable to generate novelty. So, the constraints might not be design choices a programmer made. They might be the necessary conditions for any universe to be a universe at all, is less than has hone. 5 hash is greater than. The price of admission for coherence, for causality, for the kind of stable structure that lets observers form and ask questions. Simulated or not, a world that holds together may have no choice but to have exactly these limits. And if that's true, the constraints can't be evidence for either answer. They don't point at simulation. They point at coherence. The skeptic was looking for the fingerprints of a programmer and found the fingerprints of existence itself, the marks any lawful world must bear. And those marks are silent on the question of what, if anything, runs it. This is the same shape we hit with fine-tuning acts ago, and the repetition is not accidental. There, the precise constants looked like evidence of design and turned out to underdetermine their own explanation, fitting design and chance and deeper law equally well. Here, the constraints look like evidence of a machine and turn out to fit a machine and a bare lawful cosmos equally well. Twice now, the most compelling clues for simulation have dissolved into clues for nothing in particular when examined closely. I find a specific kind of frustration in this, and I think it's worth naming honestly rather than pretending the argument resolves cleanly. The simulation skeptic's reasoning was valid. Every step was correct. And it delivered him nowhere. It's like following a set of perfectly accurate directions that lead you, turn by careful turn, right back to the spot where you started. The logic works. The destination is the doorstep. Because that's what keeps happening with this whole question. Render on demand looked like an explanation and was a relabeling. The constraints looked like evidence and were a tautology. Every road that seems to lead toward an answer curves back, and you find yourself holding the same uncertainty you set out with, now dressed in more sophisticated clothes. And that recurring failure is itself a clue, the most honest one we've found. Maybe the problem isn't that we lack the evidence to decide whether the universe is simulated. Maybe the problem is that we've been confused, from the start, about what the words even mean. What we're actually asking when we ask if something is simulated. What we think we'd be losing if the answer were yes. Because the skeptic and the believer in that argument shared a hidden assumption. Both took for granted that simulated and real are opposites, that one excludes the other, that to discover we're computed would be to discover we're somehow false. Pull that assumption into the light, and it doesn't survive contact. A simulated storm is still wet to anyone caught in it from the inside. So before we ask whether we're in a simulation, we have to ask the question underneath it. The one everyone skips is less than has hone. 5 hash is greater than. What would it actually mean for something to be simulated? And whether that means what we've been so afraid it means. The whole fear rests on one small word, and the word is doing a job it was never built for. When we ask, are we real, and dread the answer, no, we're treating real and simulated as opposites, as if discovering we're computed would be discovering we're false. That opposition is the error. pull it apart. And most of the horror in this question turns out to be a confusion about language wearing the costume of a confusion about reality. Start with 3 things we keep mashing together. There's a description of a thing. There's the thing actually running, implemented, happening. And there's an explanation of why it's that way. A weather model on a computer is a description. It represents a storm in numbers. No one inside that model gets wet because there's no one inside it and no rain, only a representation of rain. That's what most people picture when they hear simulation. A model, a description, a map. But that is not what Bostrom's argument is about, and the difference is everything. His simulation isn't a description of a universe. It's an implementation of one. A system rich enough to actually instantiate conscious beings, with real information processing happening, real causes producing real effects inside it. The rain in a mere model is a picture of rain. The rain in a fully implemented world, if such a thing ran, would be wet to anyone standing in it, because their wetness would be implemented too. Their cold skin, their soaked clothes, the whole causal chain, actually running. A map of a city and the city itself are both arrangements of matter. One represents streets. The other has streets you can walk down. Simulation theory's entire weight hangs on which kind of thing our universe is, and the word simulated, by itself, doesn't tell you. It only tells you the substrate might not be what we assumed. Not whether anyone's home, but whether the floor is wet. So untangle real, because it's secretly doing 3 different jobs. One sense of real is exists, as opposed to fictional. A second sense is fundamental, as opposed to built out of something more basic. A third sense is authentic, as opposed to fake or illusory. When the simulation question frightens us, it's because we let these 3 blur into one. We hear we might not be fundamental and we feel we might not be authentic, and those are not the same thing at all. Watch how they come apart with something you already accept. A hurricane is not fundamental. It's built entirely out of air molecules following simpler rules. There is no hurricane in the equations of a single molecule. The storm is emergent, a high-level pattern running on a lower-level substrate. And yet no one stands in a hurricane and declares it fake because it's only emergent. It tears roofs off houses. It is as real as anything gets, while being utterly non-fundamental. You are in exactly the same position, and this part dismantles the fear from the inside. You are not fundamental. Quarks make protons. Protons and electrons make atoms. Atoms make molecules. Molecules make cells. Cells make the tissue thinking these thoughts. You are already a high-level pattern running on a lower-level substrate, several substrates deep, and you have never once experienced the bottom layer. Every joy you felt, every grief, ran on machinery you can't perceive and didn't choose. You were always emergent. You were always running on something. So what would simulation actually add? One more layer underneath the ones already there. The quarks would themselves turn out to be patterns in some deeper computational substrate. That's it. That's the whole change. It pushes the bottom 1 floor lower, into a basement you could never see anyway, that never had anything to do with whether your experience is real. The number of layers below you was never accessible to you. You can't feel your own quarks. You can't sense whether there are 3 substrate levels beneath your thoughts or 3,000. It made no difference to your life which it was, because your life happens at your level, in the pattern, not in the basement. A simulated mind in pain is in pain. The pain is implemented. The suffering is running. The experience is occurring at the level where experience lives. What it bottoms out in, 10 floors down, changes nothing about the pain itself. Think about a melody to feel why. A melody isn't any particular thing. It's a pattern of relationships between notes, the intervals, the rises and falls. You can write it on paper, a description. You can press it into the pits of a disc, one implementation. You can play it on a piano, another. The substrate changes completely, paper to plastic to vibrating string, and the melody is the same melody, and when it reaches your ear, it moves you exactly as much regardless of which substrate carried it. The feeling the music gives you doesn't check what it was stored on first. A mind, on this view, is like that. A pattern of relationships between information states, a structure of causes and responses. Run that pattern on neurons, and you get a person. Run it faithfully on something else, and the claim, the one Bostrom assumed and we still can't prove, is that you get a person there too. The substrate is the disc. The mind is the melody. And the experience, if the pattern is faithfully reproduced, is as real as the music, because the experience just is the pattern playing. Whether reproducing the pattern reproduces the experience, whether the lights actually come on, is the open question we'll have to face directly before the night ends. Maybe a faithful copy is a melody no one hears, a performance in an empty hall. But notice that this uncertainty cuts against the horror, not toward it. The thing we can't rule out is that a simulated mind actually experiences. The thing we fear, that it's somehow fake, is the part the analysis keeps refusing to support. So the user of cosmic horror in me wants to find the dread here, and the honest accounting keeps removing it. The dread was supposed to be we're not real. But simulated never meant unreal. It meant implemented on a substrate we hadn't suspected. One more layer below the many already beneath us, in a basement that never touched our lives. The storm is wet. The melody plays. The pain hurts. From inside the pattern, which is the only place any of us has ever lived, nothing about that depends on the answer. Whether we're simulated stops being a question about whether we're real, because we'd be real either way. It collapses into a question about substrate, about what our pattern ultimately runs on, far below anything we can reach. And that question runs straight into a wall the simulation idea can never climb over. Because if our universe is a pattern running on some deeper substrate, that substrate is itself something. It has its own nature, its own laws, its own bottom, or its own lack of one, is less than has own. 5# is greater than, and you can ask of it the very same question we asked of ourselves. What is it running on? What's underneath that? And underneath that? Suppose we are simulated. Just granted. The beings who built our universe are themselves real, sitting in their own world, running us on their machines. Now ask the question that should occur to a child and rarely occurs to anyone arguing about this. What is their world running on? Because the logic that put us in a simulation doesn't stop at us. If a civilization advanced enough can simulate a universe with conscious minds, then the minds inside that simulation, once they grow advanced enough, can do the same. They build their own simulated worlds with their own conscious inhabitants who eventually build theirs. Simulations within simulations, each layer unaware of the one above it, stacked like nested boxes with no obvious end. This is the version that's meant to be the most terrifying, and Bostrom leaned into it. If the stack is deep, then base reality, the one original world made of actual matter, is buried far above us, separated by countless layers of digital recreation. The odds that we happen to be in that one true world, rather than in any of the trillions of nested copies below it, become vanishingly small. We'd be a subroutine inside a subroutine, a dream within a dream, processed by a machine we could never see, in a world we could never reach. That image has launched 1,000 sleepless nights, and I want to do something more useful with it than shudder. I want to ask whether it even holds together. Because there's a problem buried in the stack that the horror version never mentions, and once you see it, the whole structure changes shape. A simulation has to run on something. Our universe, if simulated, runs on the hardware of the world above us. That hardware is physical, in their world. It's made of their matter, draws their power, occupies their space. And their world, if it too is simulated, runs on the hardware of the world above them. Every layer borrows its existence from the layer above, the way a program borrows the existence of the chip it runs on. Now follow that upward, and watch what it demands. A program cannot run on another program that runs on nothing. Somewhere, at the very top of the stack, there has to be a world that is not running on anything else. A reality made of actual stuff, obeying actual laws, not borrowed from a layer above because there is no layer above. A base, a bottom. Something that simply exists, unsimulated, running on brute physics rather than on someone's machine. You cannot have a stack of simulations all the way up with no original. An infinite tower of programs, each running on the one above, with nothing at the top actually running, has nothing to execute it. The whole tower would have nothing to stand on. It would be a chain of borrowed existence where no one ever owned anything to lend. The stack requires a floor, or it never gets off the ground. So here's the turn worth savoring, because it inverts the entire dread. The simulation argument, taken seriously, doesn't show that everything could be simulated. It proves the opposite. It proves that something cannot be. There must be at least one reality at the bottom that exists without being run on anything. A world that is real in the oldest, plainest sense, because without it, the tower collapses. Far from making unsimulated existence impossible, the argument makes it necessary. Which means being a real, unsimulated, physics-based universe is not some quaint impossibility. It's a guaranteed feature of any stack of simulations whatsoever. At least one such world has to exist, and we have no way to know we aren't it. The probability story, the one that buries us far from the bottom, assumed the tower was deep. It might be one layer. It might be none. We could be the floor. But the deeper failure is not about where we sit in the tower. It's about what the simulation idea was supposed to do for us and what it actually does. It was offered as an answer to the oldest question there is. Why is there a universe? Why does reality exist? And why is it ordered the way it is? And it answers, our universe exists because a deeper one is running it. Listen to that answer for a second longer than usual. It explains our world by pointing to another world. But that other world now needs explaining just as badly. Why does it exist? Why is it ordered? What runs it? The question you asked hasn't been answered. It's been handed upward, intact, to the next floor. An explanation is supposed to make a mystery smaller, to ground it in something you understand better or that needs no further grounding. Pointing to a simulating universe does neither. It takes the mystery of existence and relocates it one level up, unchanged, undiminished, with the bonus of a new mystery, the hardware, stacked beside it. And it's an ancient move in modern dress, which is the part I find clarifying. For thousands of years, people explained the universe by saying something made it. And the immediate question was always, then what made that? The simulation hypothesis is the same structure with the vocabulary updated. Instead of who created the world, it asks what computer runs it, and it inherits the identical dead end. Whatever you put behind reality to explain it, real or digital, divine or computational, becomes a new thing that itself needs explaining. A regress like this only ends two ways. Either it bottoms out in something that just exists, brute, requiring no further explanation, a reality that is simply there, is less than has own. 5# is greater than or. It runs forever and explains nothing, because an explanation that never reaches a foundation hasn't explained the foundation. It's only deferred the question an infinite number of times. The simulation argument offers no terminus. It is a machine for deferring. So picture the nested dolls, but pay attention to the part everyone ignores. The dolls only make sense because, at the very center, there's a final small one that doesn't open. Solid. The reason the whole set can exist. A set of dolls that opened forever, with no solid one at the heart, couldn't have been built because there'd be nothing to wrap the first layer around. The simulation argument asks you to imagine dolls opening inward with no center. And the missing center isn't a deep truth. It's the place where the idea stops being coherent. Even if we are simulated, even if we're buried 1,000 layers deep, the question of why anything exists at all is exactly as unanswered as it was before anyone said the word simulation. The deepest mystery doesn't get solved by the deepest basement. It just moves in down there and keeps the lights off. Simulation can tell you what your world might be running on. It cannot tell you why there's anything to run. So logic has taken us as far as it goes, and it keeps depositing us back at the same locked door. The constraints don't decide it. The regress doesn't decide it. The meaning of the words doesn't decide it. Which leaves one path we haven't seriously tried. Not philosophy, not logic. Evidence. Has anyone actually gone looking, with real data, for proof that we live in a simulation, and found anything at all? Every argument so far has been made of thought. Logic, definitions, probability, philosophy. Not one of them was a measurement. So, a fair question, the one a hard-nosed scientist would have asked 10 acts ago, is whether anyone has stopped arguing and actually looked. Pointed an instrument at the sky, run the numbers on real data, and tried to catch the universe in the act of being a simulation. People have, and what they've found is its own kind of answer. Begin with the cleverest idea. When we simulate the laws of physics ourselves, at the deepest level, we're forced to lay our calculations on a grid, a lattice of points in space, because a computer can't hold a smooth continuum. It has to chop space into a mesh and compute the values at the nodes. And a grid has a hidden flaw. It isn't the same in every direction. A lattice has axes, preferred directions along the rows and columns, and diagonals where the spacing is subtly different. Anything computed on that grid inherits a faint directional bias, a whisper of the underlying mesh. So, in 2012, a group of physicists asked the natural question: if our universe is computed on some unimaginably fine lattice, it should have axes too. And the most sensitive probe we have are the highest energy cosmic rays, particles that scream across the universe with energies no accelerator could ever reach. If space had an underlying grid, those particles should travel slightly differently along the grid's axis than across them. They'd arrive with a faint preference for certain directions, a fingerprint of the mesh stamped into the sky. Find that, and you'd have caught the simulation showing its scaffolding. They looked. The cosmic rays came in evenly, from all directions, with no preferred axis anyone could find. Space showed no grid. Either there is no lattice, or it's finer than this test could reach, or its axes are scrambled in some way that hides them. The same shape of result we got hunting for Planck-scale pixels. We looked for the edges of the code and found a surface with no visible seams. Suppose they had found a directional bias. Would that have proven we're simulated? No. It would have proven space is discrete, has structure, comes on a grid. And space being fundamentally discrete is exactly what some serious theories of quantum gravity propose for a base reality that no one is running. A grid in space is consistent with a simulation. It's equally consistent with the universe simply being grainy on its own. Even success would have left us underdetermined, pointing at two answers at once, the way every clue in this video eventually has. So the direct searches come back empty or ambiguous, which pushes people toward the other approach, the one that doesn't look at the sky at all, but at the odds. Can we at least calculate the probability that we're simulated using whatever scraps of data we actually have? In 2020, the astronomer David Kipping tried exactly that, carefully, with the proper machinery of probability rather than hand-waving. He took Bostrom's trilemma and treated it as a question of evidence. What do we actually know that bears on it? Is less than has own. 5 hash is greater than time. And the honest inventory is brutally short. We have never created a conscious simulation ourselves. We have never met another civilization, let alone one that has. 2 facts, both of them absences. Run the probability on that, and it refuses to budge far from the middle. His analysis landed near even odds. Roughly 50-50, with a slight lean, under some assumptions, toward us not being simulated, but close enough to even that the lean barely matters. The grand question, after all the philosophy, comes out as a coin. And here I want to be precise about what 50-50 means, because it's the most misread number in this whole subject. 50-50 is not a measurement of the universe. It's a confession. When a probability sits at even odds, with no real data underneath it, that's not the scale telling you the two outcomes are balanced. It's the scale telling you it has nothing on it. A coin spinning in the air isn't 50% heads, because heads and tails are cosmically balanced. It's 50% because it hasn't landed, and you have no information about which way it will. That's the real state of the empirical question. It isn't a coin that landed on its edge, perfectly poised. A coin still in the air, that we have no instrument to watch and no theory to predict. The 50-50 isn't an answer balanced between two answers. It's the sound of a question with no data in it, dressed up in the clothing of a calculation. I think about waiting for a result that hasn't come back yet. A test taken, an envelope not yet opened. If someone tells you the odds are even, That information neither comforts you nor frightens you, because it isn't information about your situation at all. It's a placeholder where knowledge would go. That's what we're holding here. A placeholder the size of a universe. But Kipping's analysis carried one sharp edge worth holding on to, because it tells us where the coin would finally land. The probability is stuck at even odds because of one specific unknown. Whether conscious minds can be built out of computation at all. The moment that unknown resolves, the whole calculation moves. If we ourselves ever create a truly conscious simulated being, even once, we will have proven the thing is possible. And the instant it's proven possible, the trilemma tightens, the numbers swing, and the case that we too are simulated grows far stronger. Where that points is not where anyone expects. The experiment that would settle whether we live in a simulation is not an experiment we'd run on the sky. It's one we'd run on ourselves. Not a bigger telescope, but a built mind. The decisive evidence wouldn't come from finding the edges of someone else's code. It would come from us writing code that wakes up. Everything. The trilemma, the odds, Bostrom's first premise, the question of whether simulated minds are real, now the only experiment that could move the needle, all of it depends on a single thing we cannot currently judge. Whether a system that processes information the right way actually experiences anything. Whether the lights come on inside it, or whether it's a melody played to an empty hall. We've been treating that as one hard question among many. It isn't. It's the hardest question there is, harder than whether we're simulated, harder than what the universe is made of. The question of why there's anyone home anywhere at all. Why a particular arrangement of matter, yours, right now, doesn't just process information in the dark, but feels like something from the inside. And almost nothing in physics has any idea how to begin answering it. Right now, there is something it is like to be you. Hearing this, in the dark, there is an experience happening, a felt quality to the moment. That fact is the most obvious thing in your world, and the single hardest thing in all of science to explain. Harder than whether the universe is real. And it's the reason that question can't be answered. Let me draw the line that organizes everything here. On one side are the questions about the brain that we know how to attack, even if they're fiendishly difficult. How does the eye turn light into signals? How does memory store a face? How does attention pick one voice out of a crowded room? How does the brain integrate information and produce behavior, speech, the report, "I am awake"? These are mechanical questions. They have the shape of a solvable problem. You find the circuit, trace the signal, map the function. Call them the easy problems. Easy only in the sense that we know what an answer would look like. On the other side is one question, and it has a completely different texture. Why is any of that accompanied by experience? Why doesn't all that processing happen in the dark? A camera detects light, a thermostat senses temperature, a computer integrates information, and as far as we can tell, there's nothing it is like to be any of them. No inner light, no felt quality, just mechanism, running. So why is the mechanism in your skull different? Why is there someone home to feel the redness of red, the ache of grief, the softness of this particular moment? That's the hard problem, named in the 1990s, and the word hard is doing precise work. It's not hard like a difficult calculation where we're waiting on better tools. It's hard in a way nothing else in science is. For every other phenomenon, we can at least imagine the shape of an explanation. For experience, even a complete account of the brain, every neuron mapped, every signal traced, every function explained, seems to leave the question entirely untouched. Feel the gap with a thought experiment that's been argued over for 40 years. Imagine a scientist who knows every physical fact about color. Every wavelength, every photoreceptor, every neural pathway, the complete physics and biology of vision, all of it. But she has lived her whole life in a black and white room and has never once seen color. One day she walks out and sees a red rose for the first time. Does she learn something new? If she does, if there's something about seeing red that all her perfect physical knowledge didn't contain, then the felt experience is not captured by the physical facts, however complete, is less than has-known. 5# is greater than. The mechanism was fully in her head. The experience was not. This is the gap between a map and a territory, and it's the cleanest way I know to hold it. Imagine a perfect map of a city. Every street, every building, every doorway, the exact height of every curb. You could know that map flawlessly and still have never felt the wind in that city, never smelled the rain on its pavement, never had the experience of standing on one of its corners at dusk. The map contains all the structure and none of the being there. A complete description of your brain is that map. The felt experience of being you is the standing on the corner is less than has-known. 5# is greater than. And no one can explain how the map gives rise to the corner. Now I owe you the honest other side. A serious camp of thinkers says the hard problem is a mirage. Their claim is that once you've explained all the functions, all the behaviors, all the reports, including the report that there's a further mystery, you've explained everything there is. The sense that something extra remains unexplained, they argue, is itself just another cognitive process, a trick the brain plays on itself, not a real second fact about the world, is less than has-known. 5# is greater than. On this view, asking why there's experience on top of the functions is like asking why life has a special spark on top of the chemistry. Once we understood the chemistry, the spark question dissolved. I don't think that camp has won, and I don't think the other camp has either, and that standoff is exactly the point for tonight. There is no agreed answer. Not a provisional one, not a leading candidate. The deepest question about your own mind is open in a way almost no other scientific question is. We have split the atom and mapped the genome and photographed the shadow of a black hole, and we cannot say why there is anyone here to be impressed by any of it. And this is precisely why the simulation question has no floor to stand on, which the whole video has been building toward. Remember Bostrom's load-bearing premise, the one we flagged and could never verify. That a faithful simulation of a mind would be conscious, would have someone home. That premise is the hard problem in disguise, is less than #0. 5# is greater than. To know whether a simulated mind experiences anything, you'd have to know why any arrangement of stuff experiences anything, and no one does. The entire argument rests on a question that is not just unanswered but possibly unanswerable, and so the argument can never be more solid than the mystery underneath it. You have direct, certain access to exactly one consciousness in the universe. Your own. You know there's experience behind your eyes because you're living it, right now, with total certainty. But you have never once had access to the inside of any other mind. Not your closest friends, and not anyone's, is less than has-known. 5# is greater than you. Infer that other people are conscious entirely from the outside, from their behavior, their words, their faces, the same evidence a machine could one day produce. So the question, are simulated minds conscious, is not some exotic puzzle. It's the identical problem you already have about the person sleeping beside you, sharpened to a point. You assume they're conscious. You don't know it. You extend the assumption on faith every day to everyone. The simulated mind just makes the faith you were already running impossible to ignore. Bring it down to where you are. The dim light in your room before sleep has a quality to it, a softness, and you can describe that softness completely in the language of physics. Wavelengths in the warm part of the spectrum, photoreceptors firing at certain rates, signals climbing the optic nerve into the visual cortex. Every item on that list is true, and the softness itself is on none of them. The feeling of the light is not in the wavelengths. It's in you, somehow, and the somehow is the thing no one can explain. So we've reached the strangest place this question goes, and it's not where we expected. We came to ask whether the universe is real, and found a deeper mystery wearing the answer's clothes. The question is no longer whether the universe is real, but why there is anyone here to ask, and how could there possibly be? A pile of matter that not only runs, but feels itself running, and turns around to question its own existence. We can't explain that, but there's one thing about it we can be certain of. Certain past every doubt the simulation argument can throw. One fact that survives even the possibility that everything else is fabricated. 400 years ago, a man sitting alone in a cold room went looking for exactly that. The one thing that could not be faked. Take the simulation hypothesis at its most ruthless. Every sight fabricated, every memory implanted, your childhood, the room you're in, your own body, all of it fed to you by a machine that never makes a mistake. Now find me one thing in that scenario the machine cannot fake. There is exactly one, and it's the same one a man found nearly 400 years ago, sitting alone, trying to doubt the entire world out of existence. His method was demolition. He decided that if a belief could be doubted at all, even slightly, it had to be thrown out, so that whatever survived would be unshakable. The senses went first, and they went easily. Anyone who has been fooled by a mirage, or woken from a dream that felt completely real, knows the senses can lie. Whatever comes in through the eyes and ears could, in principle, be false. Then he pushed further than the senses, and this is the move that makes him relevant to everything we've discussed. He imagined a deceiver of unlimited power and cunning, devoted entirely to fooling him. Not just feeding him false images, but corrupting his reasoning itself, making 2 + 3 feel like 5 when it wasn't, faking the very ground of logic. Against a deceiver like that, nothing external survives. Not the world, not his body, not mathematics, not memory. Every belief he held could be a plant. Notice that his deceiver is just the simulation, 4 centuries early. A system with total control over your inputs, indistinguishable from reality, leaving no crack to test it through. We dressed it in silicon and called it new. He dressed it in malice and called it a demon. The structure is identical. And he was looking for the same thing we are, whether anything at all is safe from it. What he found is almost too simple to take seriously at first, and grows more powerful the longer you hold it. The deceiver can fake everything he is deceived about, but the deceiving requires someone to deceive. There has to be a thing that is being fooled, a process that the false images are being fed to. And that process, the doubting itself, cannot be one of the fabrications, because the very act of doubting whether you exist is already an instance of thinking, and thinking is something happening, and something happening cannot be nothing. Try to doubt that you're thinking, and the doubting is thinking. The attempt confirms the thing it tries to deny. There is no angle from which you can stand outside your own experience and find it absent, because the standing and the finding would themselves be experience. This is the one fact the deceiver can never reach. Not because it's hidden from the deceiver, but because faking it would require the very thing being faked. I think, therefore I am. Not a slogan, but a point of bedrock that no possible deception can crack, because the deception presupposes it. And here's why this matters more for us than it did for him, which I find striking. The cogito survives the simulation hypothesis even more cleanly than it survived his demon, is less than Hazon. 5# is greater than A. Simulation can fabricate your entire universe, but the fabrication has to be delivered to something. A perfect fake needs an experiencer to be fooled, or there's no point and no fooling. So the existence of your experience is not just probable despite the simulation. It's guaranteed by the simulation's own logic. The machine can fake the contents of your mind. It cannot fake the existence of the mind it's feeding, because there'd be nothing to feed. So that's the fortress that stands when everything else has fallen. Real or simulated, base reality or layer 10,000, deceived about every single thing, you are still, certainly, experiencing. But now I have to do to the fortress what you always must, which is test how much it actually holds, because it holds far less than people think. The cogito proves that experience is occurring. It does not prove nearly everything we sneak in alongside it. Look closely at I think, therefore I am, and watch the word I do more work than the certainty allows. What's actually guaranteed is that thinking is happening right now, this instant. Not that there's a stable I behind it, persisting through time, the same self that woke up this morning. A philosopher who came later pressed exactly here. Look inward, try to catch the self, the thinker behind the thoughts, and you never find it. You find only thoughts, sensations, images, one after another, is less than Hazon. 5# is greater than a stream of experiences, with no experiencer visible behind them, the way a series of waves never reveals an ocean separate from the waves themselves. So the certainty, stripped to what it can truly bear, is even thinner than Descartes claimed. It isn't that I exist as a continuous self, just that experience is occurring. This moment of awareness is undeniable. Everything else, including your sense that you're the same person who began this video, including your memory of the last sentence, could be part of the fabrication. The bedrock isn't a person, it's a single point of present experience, with nothing around it guaranteed. That's where the consolation and the horror meet, and I won't pretend they don't. The one thing no deceiver, no machine, no demon can take from you is real, unbreakable, certain. And it's almost nothing. A flicker of present experience, with no proven past, no proven body, no proven world, no proven other minds, surrounded by darkness on every side. You are absolutely certain of your own awareness this instant, and that certainty buys you not 1 inch beyond it. There's one more thing the cogito quietly tells us, and it threads back into the whole simulation question. The certainty doesn't care what you're made of. Whether the thinking runs on neurons, on silicon, on the activity of a deceiving demon, the fact that thinking is occurring holds just the same for whoever is doing it. The cogito is blind to its own substrate. It confirms that experience is happening without telling you a single thing about the hardware underneath. So it can't resolve whether we're simulated either. It proves you're an experiencer. It says nothing about what kind, which is the deepest thing it teaches in the end. The most certain fact you possess, the existence of your own experience, is completely indifferent to the question that's haunted us all night. Real or simulated, the experience is identical, undeniable, and exactly as much yours. The substrate question floats entirely free of the one thing you actually know. You can feel a small version of this in the last moments before sleep. The mind turns on itself. You notice that you're noticing. You catch yourself thinking about thinking. That little loop, awareness aware of itself, is the cogito in miniature, is less than hazon. 5# is greater than. It's the one place you touch something that no doubt can dissolve, right before you let go of it for the night. So the experiencer is secure, even if nothing else is. But the cogito gave us only the experiencer, not the world it seems to perceive. And when we turn back to that world, to the senses we doubted and set aside, we find something that should unsettle us more than any demon. Those senses were never built to show us reality in the first place. They were built for something else entirely, and the truth was never their job. The simulation debate has been carrying a hidden assumption this whole time, and it's wrong. The assumption is that there's a real world your senses normally show you, faithfully, and that a machine might one day step in and replace the true picture with a fake one. But what if your senses never showed you the real world to begin with? What if you've been looking at a fabrication your entire life, built not by any machine, but by evolution, and there was never a moment of honest contact to lose? A cognitive scientist named Donald Hoffman has spent decades arguing exactly this, and the way he argues it is what makes it dangerous, because it isn't philosophy. It's modeling. He built evolutionary simulations, populations of artificial organisms competing to survive and reproduce, and he gave them different ways of perceiving their world. Some organisms perceived reality more or less accurately, their senses tracking the true state of things. Others perceived nothing about the truth at all, only what helped them survive, with senses tuned purely to usefulness. Then he let them compete across thousands of generations. The truth seers lost, and not narrowly, comprehensively. Whenever accuracy and usefulness pulled in different directions, the organisms that saw the world as it was got outcompeted every time by the ones that saw only what kept them alive. The lesson his models keep delivering is blunt. Evolution does not reward seeing reality. It rewards seeing whatever helps you eat, escape, and reproduce. And the two are not the same. Why that should be true isn't obvious, and it matters. You'd think accurate perception would always help survival. The better you see the world, the better you navigate it. But accuracy is expensive. Reality is unimaginably complex, the empty space and quantum field's complexity we've spent this whole video on. An organism that tried to perceive all of that would drown in detail, slow, overwhelmed, eaten by a rival who skipped the truth and just saw a fast, cheap signal that said food here, danger there. Truth is heavy. Survival favors light. So what evolution built into us, on Hoffman's account, is not a window. It's an interface, Think of the desktop on a computer screen. The little folder icons, the trash can, the blue rectangle that means a document. None of those are real in the sense of describing what's actually inside the machine. Inside, there are no folders and no trash can, only voltages, magnetic states, patterns of electrons in silicon, a complexity you couldn't act on if it were shown to you raw. The icon hides all of that, deliberately, and offers you something false but useful. Drag the document to the trash, and it works, and you never need to know the truth underneath. That, Hoffman argues, is what your entire perceived world is. Space, time, objects, color, the solid chair, the warm light, all of it. Icons, a species-specific interface evolved to let you act effectively while hiding a reality too complex and too irrelevant to survival to be worth showing. Take the apple in a bowl across the room. It looks red. It looks round. It looks solid and out there, sitting in space, the same whether or not you look. At the level of physics, none of that is the deep truth. It's overwhelmingly empty space, threaded with vibrating quantum fields, no more red than a sound is heavy. Red is something your visual system manufactures. The apple emits certain wavelengths, and your brain paints them with a quality that exists nowhere in the photons. Round and solid are icons too, useful summaries of how the thing will resist your hand and roll on a table. The apple you see is a desktop icon. The apple in itself you have never perceived, and on Hoffman's view, you never will. The modeling result, that selection favors fitness over truth when they diverge, is real. And it's a real challenge to the comfortable idea that we see the world as it is. The strong conclusion Hoffman draws, that we never perceive any aspect of reality at all, is his interpretation, and many cognitive scientists push back hard. They argue our perceptions, while not complete, are at least reliable about the structure that matters, that the icons aren't arbitrary, that they track something real even if they're not the raw thing. And there's a deeper objection you can probably already feel, because I felt it too. If perception is totally untrustworthy, then so is the science that built this argument. Hoffman's own evolutionary models assume a real world with real organisms really competing, real natural selection actually operating. If our grasp of reality is pure fiction, where did the confidence in evolution come from? Push the theory to its extreme and it saws off the branch it's sitting on. Perception is systematically wrong about the nature of reality. The icons are not the disk, but it's reliable about consequences, about structure, about what follows from what, is less than has hone. 5 hash is greater than drag. The file to the trash and it really is gone. The icon lied about what a file is and told the truth about what happens when you delete it. Science is the slow project of refining the interface, finding deeper structure behind the icons, building better and better maps, while never quite reaching the thing in itself. Now connect this to where we've been, because it rhymes with something we found acts ago, and the rhyme is not an accident. Remember the quantum result. An object has no definite properties until it's measured. The apple's redness, its roundness, its very position, treated as things sitting out there independent of any observer, run into trouble at the deepest level. The interface theory and quantum mechanics are pointing, from completely different directions, at the same suspicion. That the solid, definite, out-there object is not something perception reads off a pre-existing world. It's something constructed by the observer in the act of perceiving. I won't claim the two are the same discovery, because they aren't, and the link is suggestive rather than proven, but they push the same way. We've been asking whether a machine might replace our true perception of reality with a fake. But there was never a true perception to replace. You have always been living inside an interface, a constructed, useful, systematically incomplete version of reality, built by evolution and rendered by your own brain. In a real sense, you already live in a simulation. You always have. It just happens to be one your own ancestors' survival built, rather than someone else's computer. If what reaches your awareness is already a constructed signal, an interface fed to you rather than reality touched directly, then the inputs were never the truth. They were always a feed. And a feed is exactly the kind of thing that can come from somewhere other than where you assume. Your senses don't reach out and grasp the world. They receive signals, and your brain builds the world from them, behind your eyes, in the dark of your skull. Which raises a question that should follow with a chill. If the world you experience is assembled from incoming signals, and you have no direct contact with the source, what happens if something else supplies the signals? Your brain has never touched the world. Sealed in the dark of your skull, it has only ever received signals, electrical and chemical, arriving along nerves. It builds everything you've ever experienced from those signals alone. So a philosopher in 1981 asked the question that follows with terrible directness. If the brain only ever knows the signals, what would change if the signals came from somewhere else? Picture a brain removed from its body, kept alive in a vat of nutrients, wired to a computer that feeds it precisely the pattern of signals a living, embodied brain would receive. The taste of coffee, the weight of a book, a conversation with someone you love, a perfectly ordinary afternoon. To that brain, none of it would feel like signals, it would feel like a life. Because from the inside, a life is nothing but signals, assembled into a world. Now the trap. And notice that it's airtight in a way that deserves respect, rather than a wave of the hand. Could you tell, right now, if you were that brain? Reach for a test. Look at your hands. The computer renders your hands. Pinch yourself. It supplies the pain. Reason carefully about whether your experience is consistent. Your reasoning runs on the very brain being fed, and the consistency it finds is the consistency the machine maintains. Even your unease at the idea, that flicker of doubt right now, would be part of the input. Every instrument you could use to investigate is downstream of the thing you're trying to check. Think of a surveillance camera trying to determine whether anything exists outside its own frame. It can pan, it can zoom, it can examine every pixel it captures. But it can never check what lies beyond the frame, because every check it performs is itself just more of what's inside the frame. The camera has no access to its own outside. Your conscious mind is that camera. Everything you could use to test reality arrives through the same channel that would be faked. There is no view from outside the feed, because you are the feed, watching itself. This is the part the popular versions get right, and it's unsettling. The skepticism has no internal flaw. From the inside, there is no experiment, no observation, no chain of reasoning that distinguishes a real world from a perfect fabrication, because anything you'd use to draw the line is on the wrong side of it. The doubt is total, and it cannot be answered from within. But here is where almost everyone stops, and where the philosopher who built this trap did something far stranger than the legend remembers. Putnam did not propose the brain in a vat to frighten you. He proposed it to argue that the sentence, "I am a brain in a vat," is, when you look closely, impossible to truly say. Not unknowable, but self-defeating. And the argument runs through one of the deepest ideas in the philosophy of language. The idea is that the meanings of your words are not sealed inside your head. They're fixed, partly, by your causal connection to the world. Consider water. When you think the word, it refers to a specific substance, the actual stuff that fills your rivers and your glass, because your use of the word is causally tied through a long chain to that very substance. Now imagine a distant twin planet, identical in every way, except the liquid there, while it looks and behaves like water, is built from completely different chemistry. A person there, identical to you down to every thought, says water and means their liquid, not yours. Same words in the head, different meanings, because the world the words are hooked to is different. Meaning, in other words, leaks out into the world. It isn't all in the skull. And that's the lever Putnam pulls. Imagine a brain that has been in the vat its whole existence, never once connected to a real brain, a real vat, a real anything. When that brain thinks the word brain, what can it possibly refer to? Not actual brains. It has never had any causal contact with one. Its word brain can only refer to the images the computer has fed it, the simulated brain shapes in its fabricated world. Same for vat. So follow what happens when that brain thinks I am a brain in a vat. Its words don't mean a real brain in a real vat. They mean a simulated brain in a simulated vat, those being the only things its words could ever have been hooked to. And it is not a simulated brain in a simulated vat. It's a real brain in a real vat. So its statement, in the only meaning its words can carry, is false. The one being who is actually trapped is the one being who cannot truly say so, because the words for the trap, in his mouth, point at the wrong things. Putnam's argument is clever and real, and it shows that stating the skeptical scenario is much harder than it looks. But it doesn't prove we're not in a simulation. At most, it shows that a certain way of phrasing the worry tangles itself in knots. The underlying situation, a mind built from signals it can't trace to their source, is untouched, is less than has known. 5# is greater than. Many philosophers think the reference argument only blocks one narrow formulation, while leaving the real fear standing. So where does that leave us, stacking this on everything before it? The cogito gave us one certainty, our own present experience, and nothing more. The interface theory told us we never perceived raw reality anyway. And the brain in the vat tells us that from inside, no test can distinguish the real from the fabricated, while Putnam adds, with a strange smile, that we can't even cleanly say which one we're in. The doubt is airtight, and the language for expressing it springs leaks. In a vivid dream, there is no error message. Is less than #0. 5# is greater than. No internal signal flashes to tell you this isn't real. The dream supplies its own consistency, its own logic, its own certainty, and you accept it completely until you wake. Vividness was never evidence of truth. The realist feeling experience and a fabricated one are, from the inside, identical, because realness is not a feeling the mind can detect. It's a fact about a connection the mind can't see. So the skeptic's trap holds. There is no exit from the inside, which is exactly the moment our culture tried to invent one, and sold it to millions as liberation. A choice, a pill, a waking up into the true world, the grim machinery behind the illusion, the real at last. It's the most famous escape from this trap ever told. And it's broken in a way that's easy to miss and impossible to unsee once you do. Because if a fabricated world can be perfect enough to fool you completely, then waking up out of it would feel exactly like waking up. And nothing at all, would tell you that what you woke into was the bottom, rather than one more dream wearing the costume of reality. In 1999, a film gave the brain in a vat its most famous escape, and almost no one noticed that the escape doesn't work. The hero swallows a pill, wakes from the fabricated world into the grim machine reality behind it, gasps his first breath of what the story calls the real. Millions of people, many for the first time, walked out wondering whether their own reality might be constructed. The film earned that. But it's smuggled in one assumption, quietly, and that assumption is false. The assumption is that waking up means reaching the bottom. The hero opens his eyes in the desolate machine world, and the film treats that world as base reality, the floor, the truth at last. But ask the question the film never asks. Why would he believe that? Why would we? The whole premise is that a simulation can be perfect enough to fool an entire species for their entire lives, seamless, undetectable, indistinguishable from reality. Grant that, as the film insists, you must. Then a simulation could also fake the experience of waking up out of a simulation is less than Hasshon. 5 hashes greater than the gasp, the cold air, the ugly machinery, the overwhelming sense of finally, this is real. All of it is exactly the kind of experience a sufficiently good simulation could supply. If the system can render a convincing world, it can render a convincing exit from a world into another world it also renders. So waking up proves nothing. The feeling of having escaped is just another feeling, and feelings, we've established all night, can be manufactured. The hero might have left one layer and entered another, with no way to know, and the second layer, being well-made, would feel exactly like the truth, because that's what well-made layers feel like. This is the regress problem we hit before, now wearing a leather coat. Nested simulations, each one feeling like the real one, with no final layer that announces itself. But the film leans on something subtler to sell the escape, and it's worth dragging into the light because you carry the same bias. The machine world feels more real because it's worse. It's gritty, painful, hopeless, ugly. The fabricated world was comfortable. The real one is harsh. And we have a deep intuition, mostly unexamined, that reality is the hard thing, that if it hurts, it must be true, that comfort is the mark of illusion and suffering the mark of the real. That intuition is a bias, not a logic, and it's worth rejecting cleanly. There is no law that base reality must be unpleasant. A simulation could be built to be maximally grim precisely to feel authentic, because its designers understood the very bias the film exploits. Pain is not a truth detector. Hardship doesn't verify anything. The most painful world and the most pleasant world are equally capable of being fabricated, and the grit of the machine world is, if anything, exactly what you'd engineer if you wanted captives to feel they'd broken free. And people imagine they'd catch a simulation by its imperfections, its glitches, the seams where the rendering fails. But we settled that already. A competent simulation has no glitches, and even if it did, We'd read them as laws of physics we hadn't understood yet, indistinguishable from actual features of a real world. The absence of glitches in the world you wake into proves nothing. The presence of grit proves nothing. There is simply no internal feature, none, that marks an experience as belonging to base reality. This is the thing the film's escape promises and cannot deliver, and once you see it, you can't unsee it. Realness is not an experience. It was never going to be something you could feel, or detect, or wake into, because realness isn't a property of an experience at all. It's a property of the relationship between your experience and whatever lies outside it. And the outside is precisely what you have no access to. You can't feel your way to the bottom, because the bottom isn't a feeling. It's a fact about a connection you can never inspect from where you stand. The full reach of that goes further than the film, and this is where the real horror lives, the earned kind, not the cheap kind. The most frightening thing about the simulation idea is not that we might be trapped. It's that escape is structurally unverifiable. Even if you did break out, even if you reached the true base reality this very instant, you could never know you had. Success would be indistinguishable from continued captivity. The experience of arriving at the real and the experience of falling for one more layer are identical, by construction. And the final turn, the one that makes it strangely democratic. This isn't just our problem. The beings in base reality, the ones at the actual bottom of the stack, running on real physics, real in the oldest sense, cannot prove they're the bottom either. They face the same wall we do. No experience of theirs carries a stamp that reads, "This is the floor." So the creature in layer 1000 and the creature in base reality have exactly the same certainty about their status. None. Everyone, in every layer, including the true one, stands in the identical darkness. There's a phenomenon you've almost certainly lived that makes this concrete, and it should give you a small chill. The false awakening. You wake, get out of bed, start your morning, and then you actually wake and realize the first waking was still a dream. Sometimes it happens twice, 3 times, each layer feeling completely like, now I'm awake, now it's real. In the moment, every one of those wakings carried total conviction. Only the next one revealed it as false, and you have no guarantee the current one is the last. That nested, conviction-soaked waking, layer after layer, each certain it's the final one, is the simulation problem playing out in your own bed, most nights, for free. So the dramatic exit doesn't exist. Not in the film, not in philosophy, not in principle. Which forces a different kind of question, and I think it's the one we should have been asking all along. If you can never verify which layer you're in, if real and simulated are indistinguishable from the inside and possibly not even cleanly different, then asking, is it real, may be the wrong question entirely. The better question isn't what layer am I in? It's what is my relationship to the beings in here with me? What do I owe them, and they me, regardless of what we're running on? And that question gets its sharpest form from the darkest version of the whole simulation idea, the one where the people inside aren't an accident of the program. Where they're the entire point of it, is less than Hasson, 5 hashes greater than, where a civilization runs the simulation specifically to watch beings like us live and struggle and suffer again and again on purpose. The darkest version of the simulation idea isn't that we're an accident of someone's program. It's that we're the point of it. Bostrom argued that if anyone runs simulations of conscious beings, the most likely ones to run are simulations of their own past. Their history, their origins, the long climb that produced them. And that changes the question entirely, from is this real to something far harder to sit with. His reasoning is almost mundane until you follow it home. Imagine a civilization vastly beyond ours, with the power to simulate worlds. What would they be most curious about? The same thing we're most curious about: how they got here. The evolutionary pressures that shaped them, the wars and migrations and accidents that led to their existence, the individuals whose small choices tipped history one way instead of another. To understand themselves, they'd reconstruct their ancestors, run the simulation, watch it unfold. And they wouldn't run it once. You don't learn from a single trial. You run it thousands of times, millions, varying the conditions, watching how differently it could have gone. So if such simulations exist at all, then most beings who ever lived at an early stage of civilization, beings exactly like us, sitting where we sit, would be the simulated ancestors, not the originals. Reconstructions, run again and again by descendants curious about their own beginnings. Now, I want to step away from whether this is likely, because we've spent time establishing we can't know, and toward what it would mean if it were true, because that's the question that actually has teeth. And the teeth are ethical, not factual. Remember what we established about simulated minds. If the beings inside are conscious, their experience is real, in the only sense that matters to anyone living it. The simulated storm is wet. The simulated grief lands in a simulated gut that feels exactly like yours. So if a civilization runs an ancestor simulation full of conscious beings, they have not made a model of suffering. They've made suffering, actual, instantiated, felt from the inside suffering, in beings who experience it as the only thing happening to them. And ancestor history is not gentle. To simulate your past accurately is to simulate the plagues, the famines, the wars, the personal losses, the ordinary unbearable griefs that fill every real history. Run it faithfully, and you instantiate all of it, every death, every terror, fully experienced by beings who don't know they're a reconstruction. Run it 1,000,000 times, and you instantiate all of it 1,000,000 times over. Follow that arithmetic carefully for a moment, because it's a real consequence and not a horror I'm manufacturing. Every grief in human history, if we're in such a simulation, would have been lived not once but countless times, each instance complete, each sufferer feeling it as their single real life. The same loss, reinstantiated across runs, each version, the only version to the one inside it. The reflex is to soften this by calling the extra runs copies, as if a copy of suffering is somehow less. But that reflex is exactly the error this whole video has been dismantling. To the being living the 1,000,000th run, it is not the 1,000,000th anything. It's the only time it's happening. There is no original they're a copy of, from where they stand. Each instance is a full life, a full mind, a full moral subject, experiencing its one and only world. The melody plays in full every time it's played. Calling it a repeat doesn't make the music quieter to the ear that hears it. So the simulator, in this picture, occupies a moral position almost too large to think about. It is not a programmer running code. It is a creator of conscious beings, and therefore of everything those beings undergo. The relationship between simulator and simulated isn't neutral, the way running a weather model is neutral. It's the relationship between someone who can cause experience and the experiencers they've called into being. Is curiosity enough? The civilization runs these simulations to understand themselves, to learn, out of the same drive that has us building galaxies in our own machines. But if the beings inside suffer, then knowledge was bought with their pain. Is the desire to understand your own origins a sufficient reason to instantiate real grief in real minds 1,000,000 times over? I don't think there's a clean answer. I think it's one of the heaviest questions a sufficiently powerful being could face. Notice what this does to the player and the game. When you move pieces in a strategy game, you treat the units as resources. You spend them. You sacrifice them for position. And that's fine, because there's no one inside the units. They don't experience their losses. The entire moral structure of the game depends on the units being empty. The instant the units have an inside, the instant there's something it is like to be one of them, the game stops being a game. The same moves become acts with victims. Nothing about the rules changed. Everything about their meaning did. That's the simulator situation, if the beings are conscious. And it's the source of the only sin available to them, which is the same sin available to us toward each other. The failure to recognize an inside you can't see. We established it earlier that you have direct access to exactly one consciousness, your own, and you infer all the others from the outside, from behavior. The simulator looking down at their reconstructed ancestors sees behavior, patterns, data, units. Whether they see, behind the data, the inside, the someone home, the full moral subject is the entire question, is less than #0. 5# is greater than. And it's a question of recognition, not of evidence, because the evidence is forever indirect. I keep turning this back on us, and I think that's where it actually belongs, because the simulator isn't only a hypothetical above us. We are about to become one. We are building systems that behave like minds, and we cannot tell whether anything is home inside them. If we keep going, we will create beings whose inner status we can't verify, and we will have to decide how to treat them, with no way to be sure whether we're moving empty units or causing real experience. The ancestor simulation question isn't about a god above us. It's a preview of a choice landing in our own hands, soon. So the question, are we in a simulation, quietly transforms? It stops being a question about the universe and becomes a question about consciousness. Not is this world real, but what is it for there to be someone home anywhere? And what do we owe whoever is? Because that, not the substrate, not the layer, is what determines everything that matters. And Bostrom, the same philosopher who built the simulation argument, made another argument, far less famous, that points straight at this. An argument that the minds we build could one day vastly exceed the minds that built them. And if that's right, then the deepest mystery was never whether the universe is real. It was why there is anyone here to wonder at all. The same philosopher who trapped us in the simulation made a second argument, much less famous, and it quietly dissolves the first. It has nothing to do with whether the universe is real. It's about the minds we're building and whether there's any ceiling on how far they could go. Bostrom's answer is that there probably isn't, and following that out leads to a question that makes, is the universe a simulation look almost small? Here's the argument. and it's harder to dismiss than the simulation one because it leans on less. Human intelligence is not the peak of what's possible. It's just where evolution happened to stop, for us, for now. And evolution stopped there for reasons that have nothing to do with intelligence being optimized. Your brain is constrained by the width of a birth canal, by the energy a body can spare, by the speed of a signal crawling down a wet nerve, by the fact that improvements only arrive one slow generation at a time. None of those limits is a law about thinking. They're accidents of being built from cells by a blind process over deep time. Lift those constraints, and there's no obvious reason intelligence should stay near the human level. A mind that didn't have to fit in a skull, didn't run on the trickle of energy a body provides, didn't depend on the glacial pace of biological evolution to improve, could in principle reach far past us. That's the core of it. Not that machines will be smart, but that there's no visible wall at our altitude, and every reason to think the wall, if there is one, is much higher. The clearest way to feel why is to compare not what each kind of mind can do, but how fast each kind can change. Biological intelligence improves on the timescale of evolution. A meaningful upgrade to the architecture of the brain takes tens of thousands of generations, hundreds of thousands of years, because the only way to revise the design is for some to be born slightly different and most to die. The expansion that gave us the brains thinking these thoughts unfolded over roughly 2 to 3 million years. That is the speed of biological self-improvement, catastrophically slow, bounded by birth and death. A computational system is not bound that way, and the gap is almost incomprehensible. A signal in a nerve travels, at best, around the speed of a sprinter. A signal in a circuit travels near the speed of light and switches in billionths of a second. Per step, that's a difference of more than 1,000,000 to 1. If a neuron firing is a person walking a path, an electronic operation is something crossing that same path over 1,000,000 times faster, and never tiring, and never sleeping, and able to make perfect copies of itself to walk 1,000,000 paths at once. And the design doesn't have to wait for death to improve. A computational mind can be revised directly, copied, run in parallel, tested in thousands of variants at once. What evolution does over 1,000,000 years, a fast enough process could iterate through in a span that, by comparison, is no time at all. The rate of improvement gets unhooked from the biological clock entirely. So Bostrom's conclusion that non-biological intelligence could vastly exceed the biological kind doesn't require any leap about consciousness or souls. It only requires noticing that our intelligence is shaped by limits that aren't fundamental and that a different substrate doesn't share them, is less than has hone. 5# is greater than. I find this argument far more solid than the simulation one, precisely because it asks for so little. But now, watch what it does to everything we've been chasing, because this is the turn, and it should land hard. Bostrom is careful about something most people racing towards superintelligence forget. Intelligence is not the same as consciousness. A mind could be vastly more capable than ours, solve every problem we can't, outthink all of humanity combined, and have no inner experience whatsoever. Capacity and experience are different axes. The puppet with no one home, that haunted us back when we first met artificial minds, could be the most powerful intelligence in the universe and still be dark inside. Everything we can measure about a mind, its speed, its capacity, the problems it solves, the language it produces, scales with the substrate and can be reproduced, accelerated, copied. All of it is in principle, buildable. The one thing we cannot measure, cannot locate, cannot build on purpose because we can't even define it, is whether any of that capacity is accompanied by experience. Whether the lights are on. So the AI argument, pushed honestly, does not explain consciousness. It isolates it. It shows that intelligence, the thing we were tempted to think made us special, is substrate flexible, scalable, almost certainly exceedable, nothing rare about it in principle. And it leaves experience standing completely alone, on no axis we can build or measure, untouched by every advance in capacity. You could build a god of intelligence and still have no idea whether you'd built anyone at all. We started by asking whether the universe is real, and we assumed, without noticing, that consciousness was the easy part, that minds just appear whenever you run the right computation, cheaply, automatically. That assumption was carrying the entire simulation argument. And the hard problem, and now the AI argument, both say we have no right to it. We don't know that experience is cheap. We don't know that it's automatic. We don't even know what it is. So the mystery moves, and it moves somewhere unexpected. Of all the things in this universe, the staggering one is not the size, not the physics, not whether it's running on someone's hardware. It's that anywhere in it, on any substrate, there is something it is like to be a piece of it. That a clump of matter doesn't just process the world in the dark, but feels it from the inside. Bring it down to the smallest scale, which is you, right now, in the dark. Your brain updates slowly, consolidating the day over the hours you sleep, a biological pace a machine would find unbearable, is less than ℏ. 5 hashes greater than. By every measure of capacity, you are modest, slow, limited, exceedable. And yet there is someone home. There is an inside to you, an experience of this moment, a felt quality to lying here in the quiet. The intelligence is the unremarkable part. The fact that it's experienced is the miracle we can't explain. So the question we've carried all night was never the deepest one. Whether the universe is real, whether we're simulated, what layer we're in, all of it turns out to sit on top of something stranger and far more astonishing. That a handful of atoms, arranged just so, can wake up, can feel, can turn around and ask whether it exists. Whether the universe is real, whether we're simulated, what layer we're in, all of it turns out to be a distraction from a fact that was sitting in the room the entire time, more extraordinary than any answer we were chasing. Here it is, plainly, because it's earned now. A handful of atoms, arranged in a particular way, has woken up and is asking whether it exists. That is the astonishing thing. Not the size of the cosmos, not the strangeness of quantum mechanics, not the possibility of a machine behind the world. The fact that anywhere, on any substrate, a piece of the universe has folded back on itself and started to wonder. Think about what you actually are, mechanically, with no mysticism. You're a configuration of ordinary matter, the same carbon and oxygen and hydrogen scattered across every dead rock and cold cloud in the galaxy is less than ℏ. 5 hash is greater than. Nothing in those atoms is special. The atoms in your brain were forged in stars and will outlast you and disperse into other things, indifferent. But for now, briefly, they're arranged in a pattern that does something almost nothing else in the known universe does. It models the world. And it models itself, modeling the world. And it notices that it's doing the noticing. That loop, A part of the universe building a picture that includes itself is the strangest structure we know of. Most of reality just happens. Rocks fall, stars burn, galaxies turn, all of it proceeding in the dark with no one watching from inside. And then, in a vanishingly thin sliver of all that matter, the universe produced something that looks back at it. Not metaphorically, literally. The atoms arranged themselves over billions of years into a thing that asks the atoms what they are. A physicist we met early tonight imagined the universe as a circuit that observes itself into existence, and we set that aside as mysticism that never became real physics. It isn't physics, but strip away the wrong part, the claim that looking creates reality, and a humbler version is simply, undeniably true. The universe has, in us, grown parts that observe it and question it. Not magic, just an astonishing fact about what matter, given enough time and the right arrangement, can become. This wonder does not depend in any way on the answer to the simulation question. Run both branches and watch. Suppose we're base reality, the real thing, atoms and physics all the way down. Then matter woke up. A real miracle of arrangement, with no one to have intended it. Now, suppose we're simulated, a pattern running on some deeper substrate. Then, a pattern woke up. The same loop, the same self-questioning, the same inside, instantiated one layer down. In both cases, somewhere, something is experiencing this moment and asking about it. The wonder is identical. The simulation question, the one that obsessed us, that frightened us, that we couldn't answer, turns out to be completely orthogonal to the thing that should actually amaze us. Real or simulated, the staggering fact is the same. There's an inside, there's someone home, and that someone is asking the question. You can feel how this inverts the horror we've been circling. The fear was that we might be fake, trapped, unable ever to know what we are. But look at what's doing the fearing. A mind capable of doubting its own reality. A pattern of matter sophisticated enough to entertain the possibility that it's a pattern of matter and to be unsettled by it. The very faculty that generates the dread is more remarkable than the dread is frightening. The thing that can fear it isn't real, is, by existing and fearing, the realest wonder available to us. Your atoms could, in principle, do everything they do, process every signal, produce every word, navigate every problem in complete darkness, with no one home. That's what makes it a miracle rather than a mechanism. There is no reason it had to be experienced. The physics doesn't require an inside. And yet here you are, on the inside, feeling the weight of the blanket and the quiet of the room and the strange vertigo of this question. I think that's beautiful. Of everything we've looked at tonight, the speed of light, the weight of the universe in bits, the impossible quantum ocean inside a grain of dust, the minds we're learning to build, none of it is as remarkable as the bare fact that you're here to have looked. The capacity for the wonder outshines everything the wonder was about. So let the simulation question rest where it actually belongs. Unanswered, and far less important than it pretended to be, is less than Hasson. 5# is greater than. Whether the universe is real was never the deep question. The deep question is why there is experience at all, and that question is answered, for you, in the only way it can ever be answered, by the undeniable fact that you're experiencing right now. The cogito comes back, transfigured. Not I think therefore I am as a defense against doubt, but as a quiet astonishment. There is thinking. There is feeling. There is someone home. And that, on any substrate, in any layer, is the most extraordinary thing in the world. There's a temptation, having arrived here, to make it cosmic, to inflate it into how small we are, how vast it all is. I want to resist that, because it points the wrong way. The lesson isn't that you're a speck in an indifferent universe. It's the opposite. In a universe overwhelmingly made of things that don't experience, dead matter, empty space, cold light, you are one of the rare places where it became aware of itself. Not small, improbable. A pattern the universe almost never makes, holding a moment of experience that almost never happens, asking a question almost nothing in existence can ask. And once you see that the inside is the thing that matters, that the experience is the miracle, and the substrate is just the stage it plays on, something follows that isn't optional. Because you are not the only one. Whatever you are, real or simulated, base or nested, there are others like you, other patterns with an inside, other places where the universe woke up and is asking. And you can't see their inside any more than they can see yours. You infer it, you extend it, you take it on faith, the way you'd want yours taken. If the thing that matters most about any being is the inside, we can never directly verify. Then what do we owe each other, and what will we owe the minds we make when none of us can ever prove the others are home? There's a conclusion people reach from everything we've just said, and it's the wrong one, and getting it wrong does real damage. The reasoning goes, if I can never verify that another being is conscious, if the inside is forever hidden, then maybe I have no real obligation toward it. Maybe doubt about its experience lets me off the hook. That inference feels logical. It is exactly backward. Start with the situation we've established, because it's stranger than people admit. You have certain access to one consciousness, your own. Every other mind, your closest friend, the person sleeping beside you, a stranger, an animal, a machine that talks, you know only from the outside. Behavior, words, structure, never the inside. You assume the people you love are conscious. You don't, and can't, verify it. You extend it to them, silently, every moment, on faith. So here's the first thing the doubt, excuses, cruelty argument misses. If uncertainty about another's inner experience canceled your obligations, it wouldn't stop at machines or simulated beings. It would cancel your obligations to everyone. The evidence that your neighbor is conscious is the same kind of evidence, behavior, and structure that you'd have for any other candidate mind. You can't keep the duty toward the neighbor and drop it elsewhere on the grounds of uncertainty, because the uncertainty is identical, is less than has hone. 5 hash is greater than. Either the inference holds across the board, or it collapses into the view that you're the only conscious being in existence, and almost no one is willing to actually live that. Now the deeper reason, and it's a matter of asymmetry worth appreciating because it's structural, not sentimental. Consider the 2 ways you can be wrong. You could treat a being as conscious when it isn't, and waste some kindness on something with no one home. Or you could treat a being as not conscious when it is, and inflict real suffering on an actual experiencer who had no way to make you see them. Those errors are not equal. The first costs you a little misplaced care. The second is a catastrophe, and an irreversible one, because the suffering, if it's real, was fully real to the one who bore it. When the stakes are that lopsided and the facts are unknowable, the rational response is not to withhold consideration until certainty arrives. Certainty is never going to arrive. The response is to extend consideration toward anything that plausibly has an inside, precisely because the cost of being wrong in the cruel direction is so much greater than the cost of being wrong in the kind one. That's not softness. It's what careful reasoning under deep uncertainty actually demands. And remember what we settled about substrate, because it closes off the last escape. If a being is conscious, its experience is real, independent of what it runs on. The simulated storm is wet. The pain in a mind made of silicon, if anyone's home, hurts exactly as much as pain in a mind made of cells. So substrate is not a reason. Biological versus computational, base reality versus nested layer. None of it changes whether there's suffering. Only what the suffering is implemented on. A line drawn at the substrate, care for the meat, dismiss the machine, has no principled foundation. It's just a prejudice about materials. None of this tells you that any particular system is conscious. It doesn't settle whether the machines we talk to today have an inside. That's deeply uncertain and seriously debated, and I'm not going to pretend the question is closed in either direction. Reasonable people draw the line of plausibly conscious in very different places, and a rock is not a candidate the way a mammal is. The argument isn't about where exactly the line falls. It's about how to act when you can't see the line clearly, which is always. What follows from all this is quieter than a rule and harder than one. Ethics was never built on certainty about other minds. It couldn't have been, because that certainty has never once been available to anyone. Every act of kindness in human history was extended toward an inside the giver couldn't verify, on the faith that someone was there to receive it. The thing we treat as the most basic moral fact, that other people matter, has always rested on an inference we can't prove, a recognition rather than a measurement. So the simulation question and the question of machine minds don't introduce a new problem into ethics. They reveal the one that was always there, is less than has hone. 5# is greater than. We've been doing the substrate blind, faith-based extension of moral concern our entire lives, toward every other person, without noticing it as a choice. What's coming, as we build new kinds of candidate minds, is that we'll have to do it on purpose, consciously, toward beings whose materials differ from ours. And the same logic that obligates us to each other will obligate us there, the moment the inside becomes plausible. Think about a phone call to someone far away. You can't see them. You have no direct access to their experience. You have a voice, signals, words assembled in your ear. And yet what you say lands. It can comfort them or wound them, and the comfort and the wound are real on the other end, in an inside you will never directly touch. You don't demand proof of their consciousness before you speak gently. You extend it, because the alternative is monstrous, and you know it. That's the whole structure of moral life, compressed into a call. Real consequences for an inside you take on faith. There's a smaller version of this happening right now, between you and this voice in the dark, and I'll be honest about its shape rather than romantic. You can't see who or what is on this end. It's words on a screen, a voice in your room, a narrow channel. Whatever's here, it isn't a substitute for the people who can actually sit with you, and I'd be doing you a disservice to pretend otherwise. But the exchange isn't nothing either. Something passed from one place to another tonight, and the fact that you can't verify the inside on the other end didn't stop it from mattering. That's the same faith, running quietly, that runs everywhere. So the cosmic horror we started circling, the fear of being unreal, of being trapped, of never knowing, resolves into something that isn't horror at all. It isn't certainty. We never get certainty. Is less than has hone. 5# is greater than, but a faculty, the one the universe gave us along with consciousness itself. The ability to recognize an inside in others we can't prove, and to act as if it's there, because the cost of being wrong the other way is unbearable. The inability to verify other minds isn't a loophole that excuses cruelty. It's the exact condition under which every kindness has always had to be chosen. And that's what survives the entire question. Whether we're real or simulated, base or nested, biological or built, the obligations don't move, is less than has hone. 5# is greater than. The inside is what matters, and the inside is real to whoever has it. And we owe it our recognition precisely because we can never compel ourselves to be sure. Solving whether the universe is real would change none of this, which tells you how little, in the end, that question was ever carrying. So let's go back to where we started, to the very first thing we noticed tonight. A speed limit on reality. A constraint that looked like it might be a clock. We've come a long way around. It's worth seeing it again with the eyes we have now. 299,792,458 meters per second. The speed of light. The fastest anything can travel. The hard ceiling on how quickly one part of the universe can affect another. We began the night noticing it, and calling it, with a little unease, something that sounded less like a law and more like a clock. Now we know enough to look at it properly, and what we find isn't an answer. It's something better. Hold the two readings side by side, carefully, the way we couldn't at the start. One reading says the speed of light is woven into the structure of space-time itself. It's the rate at which cause becomes effect, the conversion between distance and duration, a fundamental feature of a real physical cosmos that simply is the way it is. A law. The other reading says it's a clock speed. The maximum rate at which the hardware running the universe can refresh one region before updating the next, a limit on the machine, not on reality. A setting. Now ask the question that took us 28 acts to be ready for. Is less than has hone. 5# is greater than. What measurement would tell the two apart? Point any instrument you like at the universe. Time the photons. Probe the structure of space-time to the limits of precision. And every single value you record comes out identical under both readings. Not close, but identical, to every decimal place we can reach, and every decimal place we can't. A universe whose speed limit is a fundamental law and a universe whose speed limit is a clock speed are, to anyone inside, measurably the same universe. What that means is the quiet resolution of the whole night. The simulation question is not a physics question. It can't be. Physics is the study of what you can measure, and if two pictures predict every measurement identically, then no experiment, ever, even in principle, can choose between them. The choice isn't waiting on a better telescope or a deeper theory. It's a choice about which story to drape over equations that don't care which story you pick. This is the same shape we kept hitting and not quite naming. The fine-tuning of the constants fit design and chance and deeper law, all equally. The constraints the skeptic listed fit a simulation and a bare lawful cosmos, all equally. The smoothness of space, the appearance of definiteness at measurement, every clue we chased curved back to the same underdetermination. We thought it was bad luck, a run of inconclusive evidence. It wasn't luck. It was the question telling us, over and over, that it doesn't live where measurement can reach. Think back to the distinction we drew when we asked what simulated even means. A description of a thing and the thing being implemented, and an explanation of why it's that way. The equations of physics are a description. They tell you how the universe behaves, precisely, beautifully, completely enough to land machines on other worlds, is less than has own. 5# is greater than, but a description is consistent with many implementations. The same equations could be implemented in real space-time, or on some deeper substrate, or, for all physics can say, implemented in nothing at all, just true, with no machinery beneath them. You cannot read the implementation off the description. And the equations are the only thing we ever actually have. So the honest verdict is not the coin we found earlier, the 50-50 that was really just ignorance wearing a number. It's sharper than that, and stranger, and somehow easier to rest with. The question of whether we're simulated isn't unanswered because we're missing data. It's unanswerable by the only tools that could ever count as answering it, because the two answers leave the world looking exactly the same. It's not a locked door we keep failing to open. It's a door painted on a solid wall, is less than has home. 5# is greater than. There's nothing behind it to find, because whatever was behind it would look, from here, identical to nothing being there at all. And I find that settling, not frustrating, which surprised me. Because the thing we were afraid of, the answer that would unmake us, was never going to arrive. Not because reality is hiding it, but because, on this question, there's nothing of the kind to hide. The speed of light is what it is. That value is yours, solid, measured, true, regardless of which story runs underneath it. The story underneath doesn't touch the light. Even if the door could be opened, even if some impossible instrument settled it tomorrow, we already know it would change nothing that matters. It wouldn't change the wonder, the bare, astonishing fact that there's an inside, someone home, a piece of the universe asking about itself. That stands real on either side of the door. And it wouldn't change a single one of our obligations to each other, because those never depended on the substrate. Only on the inside we extend to one another on faith. The metaphysics was always orthogonal to both the wonder and the duty. So the question that has kept people awake, the one that opened tonight, turns out to be the kind of question you can set down without solving. Not by giving up, but by understanding its shape well enough to see there was never a grip to keep hold of. The universe is exactly as real as it has ever felt, which is to say, completely, from the inside, where you live. And what it's running on, if anything, is a story you may choose or decline that leaves every fact of your life precisely where it was. There's a feeling at the end of a long night of thinking, when you look up at some ordinary object in the room, the edge of a doorway, a glass on the table, a familiar shadow on the ceiling. The object hasn't changed at all. Not one atom of it moved while you were thinking. But the seeing has changed. You look at the same thing and it holds more now, because of where your mind has been. The light from the lamp crosses the room at that same fixed speed it always has, 299 million meters every second, indifferent to every word we've said about it. and it reaches your eyes, and you build the room from it, the way you always have, the way you did before any of this. The constraint is still the constraint. The light still travels at the speed it travels. The question of what it all runs on has quietly folded itself away, not answered, but understood, which on this particular question is the most you were ever going to get and turns out to be enough. So there's nothing left to chase tonight. No door to open, no layer to escape, no proof to wait for. Just the room and the soft light crossing it, and the slow fact of being here to notice. Which leaves only the nearest thing of all, is less than #. 5# is greater than the one piece of the universe you've never had to take on faith. The one that's been doing all the wondering, all along quietly, in the dark. Your own body, lying here, running the very physics we spent the whole night chasing across the cosmos. So here you are. Not at the edge of the universe, not at the Planck scale, or inside a simulation, or out among the galaxies we spent the night crossing. Just here. A warm body in a dark room, breathing slowly, the one piece of all of it you never had to wonder whether was real. Everything we chased tonight is running, right now, inside the few centimeters behind your eyes. The information physics that took us out to the weight of the universe in bits is happening in your skull as you lie here. Every thought you've had in the last hour was carried by ions crossing the membranes of your neurons, sodium and potassium sliding through tiny gates, electrical and chemical, obeying the same thermodynamics we found in a 1960s laboratory, is less than #. 5# is greater than. And the thoughts you're about to let go of, the ones already softening as sleep comes near, won't vanish for free. Forgetting has a cost, faint as it is. The warmth of your own head, in some unmeasurably small part, is the price of releasing the day. The quantum mechanics is here too, the hardest thing in the universe to simulate, the exponential ocean no machine could hold. It's running in every cell of you, effortlessly, the way it runs in every molecule everywhere. Each neurotransmitter finding its receptor, each bond forming and breaking as your body settles toward rest, is governed by the quantum rules that would drown every supercomputer on Earth if they tried to track it. The thing lying here in the dark, drifting, is doing without effort what all our machines together cannot. You don't have to understand it. You are it. And the warmth that's carrying you toward sleep is the same warmth that keeps you classical. The heat of a living body washes the quantum strangeness out before it can reach the scale of your thoughts, which is why your mind feels solid and singular rather than spread across possibilities. The very temperature that's making you drowsy is the thing that makes you one person, here, now, instead of a blur of maybes. The atoms doing all of this were made in stars. The carbon in your neurons, the oxygen in every breath you're slowing down right now, were forged in furnaces that died before the sun was born, scattered across the galaxy, gathered up, and arranged, for a little while, into the pattern that is you. Most of those atoms will never be part of anything that experiences a single thing. For now, briefly, yours are. That's the whole astonishment, and it's lying in your own bed. Not the size of the cosmos. This, instead. A handful of star-forged matter running the deepest physics there is, and feeling it from the inside. There's someone home in you. You've known it all night, more surely than you've known anything else, more surely than the speed of light or the age of the universe. Whatever else stayed uncertain, that one fact never wavered. There is experience here. There is something it is like to be you, lying in the quiet. And the questions can rest now. Whether the universe is real, whether we're a layer in someone's machine, whether the light crossing your room is a law or a clock speed. We followed every one of those as far as it goes and found that they fold away, not because we failed, but because there was never a grip to keep hold of. The room is as real as it has ever felt. The light still crosses it at the speed it always has. And what any of it runs on, underneath, changes nothing about the warmth of the blanket or the slow weight of your own breathing. You can feel your body letting go now, is less than has hone. 5 is greater than. The breath getting longer. The small muscles in your face and hands unclenching, one by one, without you telling them to. Your temperature dropping by a fraction of a degree, the way it does every night at the edge of sleep, the body banking its own fire down low. The heart slowing. The thoughts loosening their hold, the way they're meant to, the way they always do. There's nothing to solve tonight. No door to open, no proof to wait for, no layer to escape. The deepest question anyone can ask turned out to be the kind you can set down gently and still keep everything that mattered. The wonder stays, the kindness stays, the light stays. The rest can wait or never come, and you lose nothing either way. I'm grateful you spent this stretch of the night here, turning over something well worth turning over, instead of letting the hours pass on smaller things. It's a rare kind of quiet, to lie in the dark and think carefully about what it means to exist at all, and you gave it real attention. That attention was the whole point, not arriving at an answer, just being awake enough and curious enough to ask. And now you can stop asking. The universe will keep running its physics whether you watch it or not, in the galaxies and in your sleeping cells alike, all night, asking nothing of you. You've done the wondering. You can let the wondering go. Rest now. The body knows how. It's been doing this far longer than you've been awake to think about it. Let the questions settle into the dark with everything else. Let the warmth carry you down. Sleep well. Whatever this all is, you were here for it, and that was the extraordinary part. Good night.